Hello and welcome to the MariaDB ServerFest 2021 edition. My name is Kai Arne and I'm the CEO of the MariaDB Foundation, and we're really happy and proud to have a great lineup of presenters here at the generic MariaDB ServerFest. You might remember that we also have server mini-fests on cloud or other release process or other subtopics. But this is the yearly generic MariaDB ServerFest, where any MariaDB related topic is welcome. So we have Steve Shaw from Intel. He's the father of HammerDB, the open source benchmarking tool. We have Peter Zaitsev, the CEO of Percona. We have Krunal Bauskar of ARM fame. We have the very always popular Marco Mäkelä of InnoDB fame. We have Jorge Torres from MindsDB, the machine learning database. We've got Seth Shelnut from TileDB and a fresh version of Valery Kravchuk's very popular troubleshooting and tracing talk. You can cherry pick from these. This is an online conference, so you have the benefit of looking at exactly the ones that are interesting to you, or look at all of them. But if you do cherry pick, there's one that I absolutely recommend you to take a look at, and that is Mikael Widenius's presentation on migration. That's a new talk and it has some intriguing new facts plus a historic overview with a totally new perspective on things. Also, another tip is you can dive into this through the Q&A sessions. So we have pre-recorded Q&A sessions with questions and answers in depth by another person than the presenter. And that's a good way to approach the topic, and it's also a good way to dive somewhat deeper in the topic. So that's a tip for you. The interactivity is another tip, and that's the Zulip channel. We have a Zulip topics for each of the presentation, which is the way for you to interact with the presenter during the presentation itself. You can ask the presenter questions, and you can approach the presenter at the podium, so to speak, even after the presentation is done and the following presentation is going on without disturbing the others, because we have separate rooms for separate topics. So that's it. Let's get going with the first presentation. Welcome to the MariaDB ServerFest 2021 edition.
Good morning, good evening, or midday, depending where you are. My name is Mikael Widenius, creator of MySQL and MariaDB, and today I want to talk about the curious case of the disappearing closed source databases. But all good stories start from the beginning. In the beginning, the source code was free. That was the source code usually come with big machines, computers, and everything was freely available, and people could learn by studying other people's code. But very soon, big corporations realized that you can make money on software and sell that independently from the hardware. There are lots of arguments why people should suddenly have to start paying for software. Because development of software costs money, and without money, the companies will not survive, so they can keep up the software, fix bugs, and give support for it. And of course, one big argument that, because when we not only want to sell it, we also want to make it closed source, so that people can study our code and try to steal our secrets. This did frustrate some people a lot, and especially Richard Stallman, who had been brought up in a community where all code is available. You can learn from other people, you can improve their code. So he started the GNU project in 1983, and very soon afterwards the Free Software Foundation. And Richard Stallman's and lots of free software developers created a lot of infrastructure needed by developers to be able to develop free software. Compiler tools, administration tools. And I remember that in the old times when I was using Sun Solaris, Unix derivata, one of the first things that you did when you got the Solaris machine is that you installed the GNU tools over it, so you could get tools that were had much better help, functionality, and so on. But even in '91, still there were some critical pieces missing. Didn't exist a free operating system. The GNU people was trying to develop Herd. The development started in 1990, but it never really became popular or stable. And when Linux was released in 1991, it basically became very soon de facto standard free operating system. Of course, you had FreeBSD and everything else, but still Linux is the most popular one. But there was still a need for a database because when the internet started to become popular, people needed a way to store the data for the web apps. So let's enter MySQL. I started development in '94. The first release was in '95. I got lots of comments from my friends while doing the development that the world doesn't need another database. Why are you doing this? There's no way that you can compete with the big closed source companies who can earn so much more money than you, and especially your code is free, so how can you make any money? And how can companies trust that MySQL actually will survive? Which is very critical for people who want to use it as the base for developing applications. What my friends hadn't taken into account was the benefits of free software, especially when doing development. I still did believe then, and still believe that doing free software and open source is a better way to develop software. And also, it was also a better way to spread the use of the product. But let's look back in time and see how did it go with some of the, back then, very popular databases. We have Informix, Ingress, Sybase, and others. If you were using some of the early versions of those has changed drastically. Some of this doesn't exist, and you can't really get support for them anymore. So just being closed source really didn't help them. And we look at the most popular relational database in the world, Oracle. They still make a lot of revenue, but they have stopped growing, especially when it comes to new users. Their software license revenues are down almost 2% over a year, and that means for a long time. And the only way that, or the main way that Oracle gets more and more money is that they have their existing customers pay more and more every year, even for the same database. So there's a lots of tricks that closed source database vendors do to get more money out of existing customers. They try to get you to pay for lots of different things. And even for smaller features, you still have to pay just to be able to enable them, like system version tables that comes by default in MariaDB. There's some tricks that I've heard from customers that wants to go away from closed source databases. That was kind of the reasoning why they wanted to do that. Not only the increased payment, but they are forced to use old machines because they can't move the database to a new machine because it has more CPUs, and suddenly the database would cost them much more without giving them any real benefits. And I also heard about customers who got commercial database for use for free for 4 or 5 years, and they were then believed that they would be able to extend that, but after the grace period was out, suddenly they got a big bill on the table and say, no, you have to pay, or you just had to install all instances of your database, which they couldn't do. And there's also people who have noticed that their contracts are such that even if they have thousands of database installations, which they are paying a lot of money for, and then they remove all of them except one, they still have to pay the full price. And some people have felt that they have been tricked into signing the documents, which is one reason that you always need to look closely what you're signing for, because there can be some things that are not logical and not what you would expect. So, considering that your closed source database costs more every year without you getting any benefits, isn't it time to start to migrate something that is more open, more trustworthy? If you go and ask your current closed source vendor, is this a good time to do? They will give you lots of reasons why you can't move, because it's so difficult, there is so big risk of doing that. And what happens if you lose data on the way? Because the migration process is difficult, and when you switch from one database to another one, you can lose something in between. And of course, you will never get proper support from an open source database. And there's lots of retraining to do, and maybe we should just take a seminar in Hawaii and discuss this. And you can have all your DBAs and managers there, so we can go through the new features in our product and see, so you can understand why you have to pay more each year. But a lot of companies I meet when I'm traveling, this was before COVID, and hopefully it will be the same when we can start traveling again, is that companies have started to be fed up with every year how to negotiate new contracts with your existing vendors where you have to pay more and more, actually for less and less. So they are looking at open source, because if you are using an open source database, most of the things that you pay for goes away. In other words, no licensing, no CPU pricing, you only pay for support. And you usually have 80 to 90% benefits of lower prices, which actually is a good thing. And you have no lock-in, which means that when you use an open source database, you can self-decide who will give you support and where do you want to run it, on which kind of hardware in the cloud and so on. So you are in charge of your own destiny. You are not a vendor that tells you that you have to use this operating system and exactly this machine and so on. And you can even be part of developing the database for your future needs, either by having your own developers do that, or contact the company who's driving the project and tell them that you are prepared to fund the features that you need in your next generation applications. But the question is how to do the migrations, because there's lots of different ways to do that and lots of different steps that you have to follow. We're going to talk about how to migrate to MariaDB, but similar rules apply to other databases. First, you should start with those applications that are using the standard feature set for the database that you want to move to. And of course, you start with the small ones that usually is very easy to migrate, can probably be done in a day or two, at least when it comes to the schemas and the data. And if your applications are using a standard set connectors to connect to the database, like JDBC or ODBC, it's usually quite easy to move a database. And you should first start with applications for which you have the source code, which is quite common in lots of industries, that you actually have that. Because if there's something that's small that you have to change, you can change it. And the last one that you should consider migrating is those that uses some feature that is absolutely critical for you that doesn't exist in your database of choice to migrate to. For example, MariaDB doesn't have materialized views. there's a ways to go around them, but you probably had to do some applications or logic changes for that. But then the nice thing with MariaDB is that you don't only can move your transactional database, you can also move your analytical database that may be in a different closed source databases, and use MariaDB for both, because the storage engine interface we have as part of MariaDB allows you to run different kind of queries. One of the nice benefits of MariaDB is that we can emulate different database constructs in different database languages. And the best strategy when you want to move your database from one system to another one is that if you can manage to do that without having to do any changes in your application. And that's what we have been able to do with MariaDB with the Oracle emulation layer. So with DBS Bank, we have been able to move 80% of their Oracle applications to MariaDB with basically or no change at all in either the application or in the store procedures. We are running them unchanged. And the biggest benefit of this is that the migration process is so much easier, because sometimes it will take time to migrate from one database to another. But even if your database and application changes while you are doing the migration process, because the schemas and the store procedures are identical on MariaDB, it's very little work to keep those in sync. And the Oracle layer we have created together with DBS can do most of the common Oracle syntax changes. And all these extensions that we do will go into the open source versions of MariaDB. So how does the migration then work in practice? I like to recommend SQLines, which is an open source tool that you can run to compare the compatibility of your application's SQL code and also your database store procedures between the database you are coming from and with MariaDB. And then you get a list of things that MariaDB doesn't support. And here you have the syntax, how to do that. And when you have got the list of the syntax, you go through it and then create a list of those things that is not supported in MariaDB. And when you have this list, then you will start to do the preparation for migration. And this is exactly how we do it with certain customers, where that wants to work together with the MariaDB Corporation and the core MariaDB developers to do immigrations. So we are using Jira as the way where we record bugs and feature requests. So we basically create a subtask in Jira for each customer, and then under the subtask we list all the functionality that they need. We can also do the subtask per application. And when all the feature requests are listed, the MariaDB engineers will go through them and then do specification for each of those, and also create a timetable for the whole application, how much development effort is needed. And when that's done, we go back to the customer who work out a time schedule and price, and then we start developing on that. And during development process, we take one task at a time, we do it, we test it, and then we make a binary where the customer can then download directly and test and verify that these new features actually works as intended for their applications. And when all subtasks is done, then we restart the real migrations of the applications, where you start by creating a text file of your database schema, all your store procedures and everything else that goes into the database. You load it into MariaDB, And then you can use either the connect engine or whatever dump facility that you have to export the data into MariaDB. And then you just have to change the connectors to use MariaDB, and then you can start test your application. And if something doesn't work, you report it in Jira, and then you either do that again, or when you get a new binary that has fixed the issues that you found, or you set up a live replication between the original database and MariaDB, so that you keep both databases in sync. And when things works, you just switch. So this is how we did things with the DBS Bank. And as I said, they already moved more than 80% of the database to MariaDB with no change in applications. So, but there are lots of iterations where we went through the feature list that they needed and everything else. But the last couple of years, they haven't needed any new features, and they've just been able to migrate easily to MariaDB. And we also noticed that there have been no issues with performance in general. There were a couple of bugs where these features where the optimizer was not as good as Oracle in a few cases, which we fixed during the testing phase. And DBS has been so happy, so they actually paid for more development of new things, like the S3 engine that was added to MariaDB 10.6. But one of the things that fascinated me most with DBS was that they took the migration process of what to migrate first, totally different to any other company that I ever met. So they told me from the beginning that the first thing we want to move is this, our biggest, most complex database. We want to take that and move that first. And I tried to encourage them that should we try with something simple. And they said, no, they want to do it this way, because there is still people who don't believe that MariaDB actually can do this. But if you take this, our biggest, most hard to move, at least our belief, application, and get that to MariaDB, not the other database user can say that, oh, my application is so complex, we can't move it, because we moved the hardest one. And that, I think, was quite smart of them, because they got a lot of buy-in within the company where they managed to move the big one. And after that, things went internally quite quickly. And the other thing they did was that when they asked for a feature, we did it, and we gave them a bit binary. Basically, they tested it almost immediately, which was great for the MariaDB developers, because if there's some bugs, you could have a very quick feedback test fix loop, which is much better for developers. So most of the Oracle features was done in 10.3. We also added some limited SQL Server syntax. But there have also been some new things added in 10.6, row num and some functions, and this was done by Vocutech. And I also expect that for 10.7 and 10.8 we will add lots of more functionality, because we have started to take migrations even more seriously than before, and trying to work together with companies to get a list of what they are missing, so we can add those to MariaDB. So conclusions. I was at the start of the DBS project, I was a little bit worried about how good will the performance be, because Oracle is a really, really great database. They have optimized that for years, and MariaDB's store procedures, will it be good enough for DBS? But we did notice that MariaDB is for their uses even if they have lots of stored procedures, really performant, and in many cases even faster than Oracle. And one of the reasons is that even if MariaDB is really fast and performant by itself, we got the additional benefit that Oracle didn't have, that we could run it on much newer hardware without any extra cost for DBS. So we got a nice performance boost there. And I always thought that most databases or database applications actually use a very, very limited set of the database. And I think that those migrations we have done within MariaDB has showed that this is indeed the case. I think that of all the databases and database applications in the world, you can easily move 90% with not too much work or cost to MariaDB. And there is 10% of the applications. We are happy to let Oracle and others have that mark. So that's what I have to say. Hope that you get inspired to move away from your costly closest database to something where you have more control, especially about your money. Thank you.
So Monty, congratulations on a very, very interesting speech. I've seen many of your speeches, but many of them are reruns in some version of something you've done before. This was a completely new one. How come?
I got inspired, and it's just a new take of things. But everything started actually with a party, a wedding just a couple of days ago, when I noticed that people don't understand why did even open source started. So I thought that would be nice to have in the talk.
Yeah, and you managed to fit it into a talk about migration. So really a good one. Thanks for that. I'll start from one of the observations that touched me personally. So you were talking about when you started creating an open source database that your friends didn't believe in you. They told things like what I told you. The world doesn't need another database. I clearly remember having said that. So now you have your I told you so moment.
Yeah, but it was kind of fun. But the thing is that back then I had customers, I had a community. So I saw that I was on the right track. The question was just, can I actually fulfill the destiny? And it looks like I was able to do that.
Yes, you were. But now, so I clearly remember me protesting and saying that the world doesn't need another database. But your explanation of your reasoning why you thought that the world did need another database, that I cannot remember at all. So is that something that you had as a hunch at that point in time, or was I just not smart enough to understand your explanation of why you did it?
It was basically, I had customers who needed it, I had needs, and I always have been customer friendly. So I tried to let them have everything they want. And they needed a database, so that kind of was it. And with my MySQL, I created a community. I was active on the email list, and there are lots of people who have needs. I tried to satisfy all of them. Well, that's why I was working so much on ensuring that every single email was answered.
Which I do remember, but in your explanation, in your excellent presentation, you came with a top-level view that seemed even smarter than that. So what you said was that, look, open source or free software had created an editor and a compiler and all of that, but it hadn't created an operating system prior to Linux, and it hadn't created a database properly in your mind. So you were sort of answering a meta need, not just the need of your customers. So when did you arrive at that insight that actually you could fill a void that is not just a void for your customers, but for the world?
Basically, after the first release of MySQL, the internal release, and we always, me and David Axmark, always want to give something back to the open source community, actually the free software community back then. And MySQL was the first project that we thought was suitable for that had there would be enough need for it.
Yeah,
That was kind of logic.
That ended well. So congratulations on that. So another thing that impressed me in your presentation, except for it being new and except for it describing things from many angles, was that it was a balanced view. So people who change the world usually are a bit fundamentalist, and at times you have had fundamentalist views, but I think this speech did not contain any of that. You gave a good logical reasoning for why closed source was created, and you gave a good logical reasoning for why databases were closed source. So, and I hope any explanation, is that just wisdom that comes with age, or why was your view here not so provocative, more like a Solomonic view?
I was trying more with the simple facts that the commercial databases, they had stopped growing. Their time is kind of out. The same thing with operating systems. So I just following the logic.
So then moving on to the actual content, you said that the open source world, the free software world, did not have a proper database. But I remember distinctly in the 90s that there were discussions about Postgres versus MySQL, and Postgres was more or less of an incumbent. So there wasn't a void. So what's your comment on that? You didn't raise Postgres all that much in your presentation.
Because in the beginning, Postgres was not a relational database. It came many years after MySQL. They had their own language. They were not SQL and so on.
Okay. So then concretely on your presentation where you mentioned DBS Bank, so lots of the viewers know what DBS Bank is, but others do not. So can you briefly present, for those who do not know that DBS Bank is the biggest Asian IT bank, can you give a short intro?
So it's based in Singapore. It's, as you said, the biggest bank in Asia, but they also are, I don't know how unique, but they have most of the software they have developed themselves, which means that in theory, they should be able to switch to any database. And because they could change the source. But the thing is that if you have, I don't know, hundreds of thousands of applications, going through all those and modify those and do migration, and you have to keep the database and application up to the sync with what you migrate to. That's a really, really tall order. And they believed in my vision of, let's do it a different way. Let's do it that you don't have to do any changes to your application, or at least as little as possible. And they believed that I could do that thanks to some of the decision makers had been using MySQL for years. I didn't know about my team's capabilities. And that's kind of the start of the discussion. And we were able to do the first version of MySQL with Oracle compatibility running within half a year with a team of only 2-3 people.
MariaDB, not MySQL.
Yeah, MariaDB, yes.
No. So there was a percentage that you mentioned there, 80% done and 20% not. I thought it was more than 80%, but do the 20% contain those applications that are not coded by DBS Bank themselves, sort of where you do not have access to the source code? Or can you comment on the 80-20?
The 80% was something said 1 year before COVID. I haven't got the new one. But as far as I know, they are trying to convert everything. I mean, but if you have thousands of applications, it takes time. So, so far, they haven't contacted me about the single applications that would be hard to move.
And what's your comment on moving applications where you do not have access to the source code, so the not house internal ones? Have they migrated any of those?
I don't know. I think they have migrated even some of those. And then the fact, as long as you can go and change the driver, you don't need to have the access to the source code. And that's the whole idea with the compatible layer. compatibility layer. Sorry.
So you had some scary stories there about how much you can be forced to pay to a closed source provider and what the conditions are. Like first you pay nothing and then suddenly you pay a lot. And you had one comment there about, well, as long as you have one single instance of the closed source database running, you need to pay for all. But that, I mean, it wouldn't make sense then to convert 80% and remain and have some 20% remaining if you still have to pay everything. So that seems to be an exception and not the rule.
No, this is something that some of the vendors have in their latest contract. And this is the way that they try to ensure that people wouldn't do or move on the databases. So this is a trap. And that's why I had the last sentence in my presentation on that page. You shouldn't.
There's something related to the IQ.
Yeah. But the thing is that you have a choice. Do you want to be with that database forever and be totally in their power that they can just go and raise your cost 10 times and you can do nothing? So the thing is that just the fact that they're doing things like this, I think is the best reason that you should try to start moving immediately to eventually get rid of it.
Yeah, so Monty, what is limiting the speed with which this migration is happening? Why it's like a no-brainer, everybody should do it, so why isn't it happening even faster than it is?
I think the biggest reason is that DBS is comfortable with what they know and what they have used for years. So there's a resistance of change within the companies. And sometimes the DBAs are not aware or don't care about the money savings that the company could do. So for migrations to actually happen for large scales within organizations, it has come from the top. But there's lots of companies who have decided that we shouldn't use certain databases. Like HP did years ago a decision that we will never use a closed source database again, and so on. And we need more of that happening. But the thing is that I think DBAs could show that they are more valuable for the companies by taking initiatives and trying to do migration themselves, just to prove that it works. Because people are afraid that will it work or not? And that's why I think that DBS Bank was so smart of first moving their biggest, hardest application that everybody said that impossible to move. They started moving that. Because after that, the DBAs had no arguments anymore.
Mm-hmm. So if I understand your algorithm or your process correctly of how you suggest that organizations migrate off closed source databases to MariaDB, it is that they do not do any porting of the application code at all. All the changes are in MariaDB server itself. And the other item here is that most of that work was already done by DBS Bank. So the usual suspects, the usual things needed when wanting to run Oracle code in MariaDB, they're already done. And now it should converge even quicker. So is that, two questions. Is that a correctly understood model? And can you elaborate in any way on that?
Yeah, the model is correct. I think that it's possible that you change your applications and people who are just in a hurry can do that. But if you have hundreds of applications, it's much smarter to minimize the changes because that also allows you to do changes in the original application before you have moved and you don't have to do anything on the other side. And looking at where we are with the compatibility layer is that most applications should move, but Oracle is a great database with lots of different options and lots of different ways to do things. So some things will be missing. And if there's missing things, then you have two choices. You change those partner applications that using those, or you come to MariaDB Corporation and ask us, give us a quote for fixing this. And my view and hope is that we will get more and more migrations done by changing the server which will help everybody to get their future migrations easier and easier over time.
So that's a great view. Is that are those your concluding words about the curious case of the disappearing closed source database, or do you have anything to add?
I should say you should start moving now, as long as you still can afford to pay for your closed source database, and go to something that is free and you are in charge of your own destiny.
Thank you, Monty. Great answers.
Okay, thank you. Thank you.
Hello, my name is Sergey Petonia, and this is a talk about improving MariaDB's query optimizer with better quality estimates. Now, before we talk about improvement, let's have some background overview. What are the selectivity estimates and why are they important? MariaDB's query optimizer is a cost-based query optimizer, so when it searches for the best query plan, it makes use of data statistics. Table cardinalities, condition selectivities, and so forth. Let's review those in greater detail. Let's consider a query, a typical join between, say, orders and line item, with some condition on orders and some condition on line item. The first number that the optimizer will going to concern itself with is the number of rows. We use the term cardinality for that. Cardinality is the number of rows. So the first we're going to look at the cardinality of table orders. Before joining this table with other table, a local condition will likely be applied, and it will filter out some records. So the optimizer will consider the number of rows left after the local condition check. We call it condition selectivity. The same goes for line item. After that, it will perform a join operation, and after join, some number of record combination will be produced, and then the optimizer will compute join output cardinality and so forth. So cardinality and as you see, cardinality and selectivity are closely related. So let's define selectivity. Let's give a definition to be on the same page. The condition selectivity is the number of rows satisfying condition divided by total number of rows. That is, it's the cardinality after the condition was applied divided by cardinality the condition before it's applied. This is a fraction, so often it is multiplied by 100%. Typical numbers like selectivity of 0 or 0% means that no rows were accepted. Selectivity of 1 or 100% means that all rows were accepted. Selectivity of 0.33 or 33% means that one row in 3 was accepted. Selectivity is very important. It's probably the most important parameter that the optimizer has to deal with. Let me illustrate that with the detail. Suppose we have now 3-table join. We are looking for customers, their orders, and the items in that order, and we have conditions on customer as well as on order and on the price of item in the order. Suppose we are considering this join, doing the join from customer, then accessing table orders, then line item. For most access methods, the cost of reading orders it depends on for how many customers you want to read the orders for. For example, if you've got twice as many customers of interest, then you will have to read twice as many orders, and it will be twice as expensive. Now, suppose the optimizer made this error, and it thinks that it will get 2 times as many customers as it will actually get after applying the condition on customer. Okay, that means that we will also think that we will scan twice as many orders. And then if the optimizer makes another error and thinks each order has 3 times as many items in it, this will end up in reading 6 more. 2 times 3, 6 more items from line item table. That is, the cardinality errors spread from one part of the query plan to another, and they are multiplied. For comparison, cost errors Cost model errors are typically don't. If you think that reading table customer is twice as expensive than it actually is, well, this doesn't spread. The reading table orders remains the same, and so will line item. So the errors in cost are added, while errors in cardinality are multiplied. And this can cause really dramatic difference for large production query with, say, 10 tables or 20. It is not uncommon to see the real number of rows read from the last table in the join to be in the matter of, say, hundreds or thousands, while the optimizer, because of all the errors in the cardinality estimation, the optimizer's estimates is in an order of hundreds of millions. Getting the selectivity wrong is the most frequent error of the optimizer, totally missing the point about what the cost of the query plan will be. So how does one compute selectivity? How does one compute this important parameter? There are two kinds of things on compute. First is the local condition selectivity, where we are interested in selectivity of conditions which are use column only one table. Actually, typically most of them is a column compared with some constant in some way. And then there is joint condition selectivity, but that is another topic. This talk will be mostly discussing local condition selectivity. Local condition selectivity. Okay, so we are looking at what can be done to predict selectivity of the conditions, like here in examples. If you open database textbook, the first suggestion will be to use so-called guesstimates. Well, if there is, for example, column equals constant, then assume the selectivity of that is 10%. Or if it is less or equal or greater than constant, then assume that condition has selectivity of 50% and so forth. This is, of course, very basic and very inaccurate because it doesn't have any information about the data distribution in the table. So, in order to get more precise estimates, one can use histograms or other kind of pre-collected data synapses. And the other option, which typically suggested in the research literature, is to perform sampling. Read a certain amount of rows in the table and see how often the condition is satisfied. MySQL and MariaDB also have some a bit unconventional way to produce selectivity estimates. These are called records-in-range estimates. Basically, the idea is that if there is an index on columns, we use the index as a really large histogram. Reading this histogram is expensive, but on the other hand, that histogram is really large and is always up to date. I'll get back to discussing records and range later in this talk. Okay, so histograms. Basic histogram, the most basic histogram to think of is a value list histogram. If you've got values, you just make a list of values and the number of times each one was encountered. Well, this works as long as the total number of values is limited and you can fit them all in the histogram. MySQL actually collects such histograms and calls them singleton histograms. But if the values do not, if there are many different values and they don't fit in your list, then you need a real histogram. When one thinks of a histogram, they typically think of something like this. There are predefined bucket bounds. Often they are also fixed, like in this picture from 10, 20, 30. And then each bar is, the height of the bar is proportional to the number of rows that got into this bucket. And this is what we think of when we hear the word histogram. Well, this kind of histogram exists. It's called equiv histogram. It's easy to collect, but it has accuracy issues. Like here we see an example that there are a few outlier values in peripheral buckets, and they take nearly half of the buckets in the histogram, while most values are concentrated in a few very popular buckets, and there our precision suffers because we don't have that many buckets. So the question is, what if densely populated regions had more buckets while sparsely populated regions had less? There is such variant of a histogram. It's called equiv histogram. Here I show the conversion of equiv with histogram on top to the equiv histogram. The idea is to put the same number of rows in each bucket, while bucket, in order to accommodate them, the bucket sizes will change. Here we see that the first bucket was cover a large range of constants because there are only a few values here, and then the buckets get smaller because the density is higher, so there is no precision degradation in the popular part of the histogram. Equiv histograms are known to have better precision than equiv histograms. Another nice property that they have that you can collect them with one pass. There exist other kinds of histograms, but which are even more precise than equiv histogram. However, they are harder to collect. And most production databases use equiv histograms. If you look at MariaDB, has the equiv histogram, although it calls it hate balanced. From version 10.0 to 10.6 and 10.7 there are another kind of equiv histogram. The same thing MySQL 8. PostgreSQL uses most common value list, and whatever is not there is put into equiv histogram. Cockroach and TIDB also use equiv histogram, and TIDB has a variant of most common value list. I put star here where the equiv histogram is actually not exactly equiv. We'll get to this in a few slides. Histograms in MariaDB, they were actually introduced quite a while ago in MariaDB 10.0. They weren't enabled by default. You needed to manually collect them, update them, and you also then needed to enable their usage by the optimizer. And the collection of the histogram was expensive because there were space consumption issues with big varchar call. So still we felt that that feature is kind of used less than it deserves. So in MariaDB 10.4 steps were made to make histograms closer to being on by default. The default settings were changed so the optimizer would use histograms if they are present. But still you need to issue some special analyze command to collect the histogram. In order to combat high cost of collecting the histogram, we have added Bernoulli sampling. Analyze sample percentage variable, which is by default is set to store where it still uses all data, or you can set it to lower value, and then histogram collection will have less overhead. The value of 0, it will actually pick the percentage to sample automatically. Well, however, it will still do full table scan and will walk through the whole table. Some details about how histogram worked in before 10.7. So as I said before, it is an equi-depth histogram which is called hate balanced. It's a little bit uncommon, not like in other databases. The histograms are very compact because the histogram is basically the story of fractions. Fraction is a number between 0 and 1, where 0 is the minimum value in the table, 1 is the maximum value in the table. Here in blue, I show what is stored for this histogram. First we store the minimum value, which is 10 here, and the leftmost bound is 0.0 because it's a minimum value. We don't actually store this number. But then we start storing this number of 40 is in the middle between minimum value and maximum value. The fraction is 42, and that is the fraction is stored. Then the next boundary between buckets is at this fraction, and so forth, and so forth, and so forth. And it ends all with the fraction of 1.0, where we store the maximum value, which is 80 for this histogram. The fractions are stored as a fixed precision numbers, so either 1 byte or 2 byte. 2-byte precision. This histogram is very compact and it works well for ranges, but it is not as good for the case where you have popular values, because you only store fractions. You don't really see if you are hitting the value or not. And for varchar columns, which where one can compute a fraction of one varchar string between two others, but that's not very precise. There is a very good demonstration of this issue in this MDF, where I have generated 1 million population of, say, users with country field, and the distribution of country field matches real country's population, so as if people were coming all over the world, and there will be like more people from China than, say, from Switzerland. And then I try to see whether collect the histogram and try to see how well it predicts the selectivity of the var condition. I run analyze command. It gives me rows. There is 1 billion. The optimizer expects to find 1 billion rows, and it actually gets 1 million rows. Then there is a filtered column, which is an estimate of how many rows will be left after this condition is applied, which fraction in percentage. And the real filtered is what was observed. And here we see that for China it's actually quite close. We expected that 22% of population will be from China. Actually we got 21. But if you take an adjacent a value that's adjacent to China, Chile, and Chile has a much smaller population, but we still get nearly the same the same estimate. Here it looks exactly the same, but it's actually a little bit off. If you use another form of explain, you can see that. Let's look at, say, other country which is not large but not close to China in the alphabet. For Sweden, we expect 4%, we get 0.15%. Well, a better estimate. So we decided to fix that, and we fixed it that it started with a GSoC Google Summer of Code 21 project by Michael Okoko, where we have introduced a new histogram type. It's called JSON HB. It stores values, not fractions. The histogram is stored as JSON. The histogram is height balanced or equi-height. It's almost height balanced. The deviation from being perfectly height balanced is that common values are put in their own buckets. So the histogram sort of includes the most common value list. And if we run the test from that MDF with JSON HB histogram, we set the histogram type, we collect the histogram, we run analyze, and now we see that, okay, China got slightly more precise. The estimate for Chile is now much better. It's a little bit off, but it's not orders of magnitude off. And the estimate for Sweden was slightly improved. So this JSON HB histogram is more precise. Let's look how it looks internally. Now I'm using a bit different dataset, a table of vehicles registered in an Australian state. But if you look at the histogram, you see that it's JSON. It starts with it is JSON object where there is one member, and there internally it has an array of buckets. Each bucket has a start value. it has a size, fraction of table rows in this bucket. As you see, this can vary. And the reason, as I already mentioned, that the popular values are their own bucket. For example, here Camry is apparently very popular in Australia, so it got its own bucket. And DV is a number of distinct values in the bucket. So you see that there's a fraction is larger than in other buckets, and this is just one value here. This is actually quite similar to what other databases store. If you look at MySQL's histogram, well, we wouldn't see much because they use this encoding. They encode the constants in base 64, but if you decode, you actually can see the values. They store minimum, maximum, cumulative fraction, and number of distinct values. The bucket, they need to store cumulative fraction because buckets may have different sizes. As far as I understand, there are two reasons. One of them is that the same as in MariaDB, popular values go into their own bucket. I think also they have the rule that each value should be in one bucket. So if the bucket boundary cuts the value in two, they will move the bucket to either to the left or to the right to make sure that each value is in one bucket. However, they don't. There seems to be a bug in this logic because I have encountered cases where the histogram was very non-equivocate with apparently suffering performance. I have filed it here, you can check out the details. Yeah, one other interesting thing is that there are holes between buckets, because here we see that this bucket begins with Caddy, this one starts with Calais, so there is a hole between values. I'm not exactly sure what was their motivation for this. If you look at other databases, for example, CockroachDB, they're also open source, so it's possible to take a look. They present their histogram as a table, although it's not stored internally that way. You can just view. And they just store the upper bound. They store the range rows is the number of rows between this bound and previous bound. So basically, number of rows in this bucket except at the end point. It's not exactly, you can see that it varies, so the histogram is not exactly equivocate. I think the cause is the same as MySQL. Interesting thing that they also store how many rows were equal to the upper bound. So basically, essentially this means that you have after each bucket you have also a singleton bucket which has just one like value that was a bucket bound and got its own bucket, denoted here in blue. I'm not sure whether this is just something that number that they got for free from their collection algorithm, or there is some deeper idea behind it. TIDB is also open source, so it's very easy to take a look. The first thing is that they store top n separately. Here you see that the Camry is put into top n, and you don't see it in the histogram. They follow MySQL that they store lower and upper bounds, so there are holes. Count is cumulative number of values, so the histogram is not exactly equivocate. Again, and they have the same thing that CockroachDB has, that the occurrence number of the upper bound. So upper bound is kind of in its own bucket. NDV is all zero here. They have two collection algorithms, so one of them apparently doesn't support it. Last one that we will gonna look at is PostgreSQL. They had the histograms way before all other databases, and it looked like this. First they take the most common values and extract them from the data, like store them separately, and then they get histogram bounds. And they just store the histogram bounds. That is, they don't. Their histogram is exactly equivocate. And they store the value at the bound. On the number of buckets that each database uses, PostgreSQL uses, by default, collects 100 most common values and then uses 100 buckets. In MySQL, the total number of buckets is 100. So if there are common values, that this one is split. CockroachDB uses 200 buckets, so it seems to be some popular number. But for non-indexing columns, the histogram always has just 2 buckets. I assume they just want to minimum and maximum value. In TIDB, I couldn't really understand their logic. The number of buckets seem to vary between 50 and 250 using some kind of rule. In MariaDB, we have histogram size 254, which gives you 254 buckets with single preg HB and half that number with double preg HB. For JSON histograms, they're not the default yet. Well, if you just don't touch it, you will get 254 buckets. Now, here it would be, one could expect like do a histogram, kind of histogram benchmark, but I decided against doing it because it's hard to do apple-to-apple comparison, because histograms are slightly different. Also, some databases use sampling, while some use full scan collection, which affects the precision. And it's difficult how to compare histogram sizes. Like, do most common values count as buckets? What are buckets with 2 bounds versus bucket with 1? Do they count as 1 bucket or 2 bucket? In general, I think that as we will see further in the talk, we don't really need to push the envelope here. Adequate histogram precision is enough. There are other issues in selectivity estimates, so probably single column histogram precision as such is not our biggest problem. Okay, takeaways for histogram. MariaDB 10.7 is getting new histogram type JSON HB. It provides histograms similar to other databases. They are almost high-balanced. Common values are included in the histogram but stored in their own buckets. Well, currently this new histogram type is not the default, but we are looking at whether we should consider making it the default in the next release. Things that are still missing, I think, is that number one is genuine sampling. So if collection was cheaper, it would be nicer. And if we had a cheap histogram collection, we could enable automatic histogram recollection. At the moment, we don't do it. The primary reason being that it's expensive. You don't want sudden spikes of workload on the server. Okay, that's for histograms. But histogram just gives you selectivity of 1 column. So what to do if your where condition typically uses several conditions on several columns? Here's an example. Suppose you want to items ordered around Christmas, and then there is also condition on item name, Christmas light, or maybe it is swimsuit. How do you compute the combined selectivity? Well, the first observation to make is that you don't actually know if these two were independent, and you need to multiply the selectivities because there is some overlap. If the conditions are dependent, then in the worst case, you just need to take the greatest selectivity. Like I suppose all Christmas lights are ordered around Christmas, but there are also other stuff ordered. In the worst case, here are the Christmas orders and here are the swimsuit orders. Maybe there is no overlap or almost no overlap. The solution number one is to use certain assumption. The first apparent thing to do is that you combine conditions on the same column. You typically can merge them together to get one range. Then the textbook suggests to assume the conditions are independent and multiply the selectivities. Or you can use the conservative estimate and try to not be too optimistic and just take the greatest selectivity and assume that the other one doesn't add anything. An interesting solution is in so-called exponential backoff, which was introduced at least in SQL Server 2014, maybe used somewhere else. We first order conditions by selectivity, the most selective go first, and then we multiply selectivity 1 by square root of selectivity 2 by fourth root of selectivity 3 and so forth. Basically, assume that we take all of the selectivity 1, half of the selectivity of S2, quarter of selectivity of S3 and so forth. This list doesn't continue because subsequent members would be closer to 1 anyway. But neither of these methods actually use any information about how are whether the conditions are correlated, and if yes, how they correlate. So the results are bad, and the real, in order to obtain the real results, you need multi-column statistics. Well, multi-column statistics, if you just collect multi-column histogram, it will take a lot of space. It will be very large in order to be any precise. Although I see that the IDB does support them. Although they have an issue which I'm not sure whether it's useful for them. In PostgreSQL, because actually in the recent versions did some improvements to support multi-column statistics. The most notable is multi-variate most common value lists. Interesting that MySQL and MariaDB have been on the forefront here for a very long time. They have records in range statistics which do provide multi-column, which are sort of multi-column statistics. Suppose you have an index on multiple columns and you have a where condition, the optimizer will build a list of ranges over this lexicographic ordering. This is a complex topic, so I can't cover it here. In MariaDB you can check the optimizer place and see what ranges are generated for your conditions. Beware, in MySQL you don't print them correctly. And then the index is used as a large histogram, and the call to query the index to tell how many rows are in certain range is called recordsinrange, and that's why they estimate recordsinrange. If you want to see this in action, let's use the vehicle registration database again. Let's create an index on car's vehicle make, and then followed by vehicle model. Then try getting an estimate on a frequently occurring combination for focus, and we get an estimate, and this is, well, the same order of magnitude, so put it within 2x of the actual amount. And then let's try a combination that doesn't exist, like Mitsubishi didn't make a focus, and we get an estimate of 1, which is basically 0 copied up in order to not cause multiply by 0, melt down in the optimizer. So you see that the estimates are actually good. If you compare that to PostgreSQL, or say typical database without multivariate statistics, you get this rows 383, which is basically multiplication of fraction of forwards multiplied by fraction of focuses, which is way smaller than the reality. And if you try Mitsubishi focus, you get a slightly lower estimate of 347. Which just the difference just explained, this is a fraction of Mitsubishi's multiplied by a fraction of focuses. So you see that the optimizer is not able to get a good estimate of single column statistics. If you add multivariate statistics here, the situation improves. For focus is in most common value list, so we get the estimate of almost 5,000, which is close to reality. However, Mitsubishi focus is not in the MCV list, and this statistics doesn't help PostgreSQL to see that this is a non-existent combination, and you still get the old multiplication of selectivities results. So takeaways for multiple statistics, for multiple condition selectivity even. The basic approach is to combine per column statistics. You assume independence or some overlap, and this becomes very imprecise because you basically have no information about how conditions are related. The advanced approach is to use multi-column statistics. This is much better. This is also much harder to do, while MySQL and MariaDB had always this non-conventional form of getting it, called recordsinrange. Okay, but with with multi-column selectivities bring certain challenges with them. Suppose you've got this condition of where a condition of which is in conjunction of multiple condition, and you get multi-column statistics. And unlike single-column statistics, multi-column statistics can overlap in all sorts of ways. Like here you see single-column statistics and there is multi-column statistics. How do you combine them to get the selectivity of the whole condition? It would be nice to somehow take them all into account and produce the estimate that uses all information. And the research papers actually show how to do that. The first one of them was published in 2005, consistently estimating the selectivity of conjuncts of predicates. It introduces so-called maximum entropy principle, which makes use of all available information from all the partial statistics that you have, and arrives at an estimate that is fair, not biased, and so forth. However, it's very computationally hard, it's slow and difficult to code this solution. Then, after year 2005, the topic kind of didn't receive much coverage from the research community, but in the recent years, there is some kind of resurrection. This is an example, one of several papers that appeared on the topic. And here the fast entropy maximization for selectivity estimation of conjunctive predicates on CPU and GPU. So this is a newer algorithm. It's still hard. It's both computationally intensive, noting that they have to use GPU for just computing the combined selectivity. And it's hard to code. I'm not aware of it being actually used in production in any database. What is used in production? Well, much basic rules, some way to prefer one statistic to another, some heuristics like statistics that uses more columns goes first. I think PostgreSQL uses that. Multi-column statistics go first. Or you can use something like try to minimize the number of independence assumptions you have to make, or pick the most selective statistics first, and so forth. What about MariaDB? In MariaDB, we are reconciling. We have been in MySQL, in MariaDB and MySQL, we have been reconciling overlapping estimates. You can find commits as early in 2006, where it was range estimates and ref access estimates, and the code that tried to reconcile them together. The issue got substantially worse in 10.4 because the optimizer now has histogram data, and it tries to use both histogram and range access data to compute selectivity, which it computes selectivity more aggressively, which causes more collisions. This resulted in poor behavior in some cases, in actually quite a bit of cases. You can watch these MDF, check out these MDF numbers. We need to fix this. We are working on this. I hope that after this talk you will appreciate that this is not that easy. The workaround for now, if you are hitting this problem with poor plan because of overlapping statistics, is to just set the optimizer to use old way to basically ignore selectivity of selectivity data from histograms. Set optimizer use case selectivity to 1. I don't have time to cover in this talk joint condition selectivity at all, which is also a fascinating topic. Takeaways. Computing condition selectivity is important, but it is also hard. In MariaDB 10.7, we've made a step forward. We introduced JSON HB histogram, which should be more precise for data with a lot of, which has very common values and varchars. The work is underway to improve selectivity computations in the optimizer. Hope we will see improvement in the next version. Thanks for your attention.
All right, Sergey, a very interesting talk. Thank you for this. It's indeed a very interesting topic. All of this optimizer related challenges. Now, we probably want to go a bit deeper into histograms, and I actually had a question that came up on DB Stack Exchange quite recently. One user there was asking something related to histograms, and that is, how often do you think one should collect histograms in MariaDB, and what is the trade-off of not doing it very frequently?
Well, it really depends on your data dynamics. For example, if you have a table that changes frequently, like you have, I don't know, web page or ad hits for this week, which you flush weekly, and then it keeps accumulating, then the data distribution changes very rapidly, and you better recollect the histogram after the flush and every day, maybe, if you. On the other hand, for columns, for example, if you have users coming from different countries or states, typically the distribution of users between states and countries for a given service states is fairly constant over time. So here a more rare update can be done. I think some other databases do it like they do it as soon as they detect that 10% of the rows have been updated, they trigger automatic recollection process, which we don't currently do because histogram collection is expensive and some people might not appreciate the background job doing a full table scan, basically.
Yeah, you're right. You did mention during your talk that if we had a native sampling, we could do this automatically. It would make it a bit less expensive. But do you think that, or do you know if the newest version of histograms is as expensive to collect as the old one? Is it slightly cheaper?
Well, it's about the same. It's also governed by, I don't remember the variable name, histograms analyze sample ratio. So you can, if it takes too much time, you can reduce the percentage, and it will get faster, but there is a limit. It still does a full table scan, basically. So it will get much faster than the old histograms.
Mm-hmm. Okay. And can you explain to me a bit about the limitations of histograms? For example, when it comes to accuracy, you did mention that JSON histograms are more accurate than the previous versions, but they're obviously not going to be 100% accurate, otherwise it wouldn't be a summary of the data. So when should I be concerned about the histogram accuracy, and where can I consider it's acceptable?
Well, the histogram accuracy, as I mentioned, the current histograms are more accurate for the cases of popular values and varchar columns, particularly varchar columns which have, say, common prefix. Sometimes the data has something it starts, all values start with, and this is supposed to be, this actually is better than the old histograms. Other than that, I don't see any big issues with histogram precision as such. I think when you have hundreds of buckets and more or less up-to-date histogram, the precision is enough. We also need to think about what do we need it for. We need it actually to come up with a good query plan. And you don't really, you have a lot of other variables, so it does make sense to strive for 100% precision of histogram. And as I mentioned in the talk, if you have queries with multiple conditions, which people typically do have, then because you need many possible query plans. If you have query with multiple conditions, the biggest source of imprecision and actual source of big error is unknown correlation between the data. So this will dwarf any imprecision of histograms.
Right. And you did mention that we have records in range, which if we have an index, that helps with getting selectivity for correlated conditions.
Yes, with indexes it helps, but well, you can't have index on fields from different tables, and there are other limitations when you can't always have an index for all possible combinations that you may encounter.
Yep, you're right. And this is particularly problematic if you have lots of indexes. The insert performance obviously goes down. And if we're talking about production performance, some people might get worried if they're trying to run analyze on big tables. Do we take any locks when we do analyze table? And does that affect the performance?
Yeah, well, the selects will still work. DML statements like inserts, deletes, updates will still work. DDL statements, I think including, we count truncate table as DDL also, those will not work. Those will wait until the analysis is completed. But other than that, regular application of qualitative DML will still continue to function. Although it will be a full table scan in the background, depends on the impact of that will depend on how loaded your system is. Let's put it this way.
Yeah, and I also assume it's down to the storage engine, which depending on the capabilities of the storage engine.
Right.
And well, let's say I have a very active master and I don't want to run analyze on the master itself. Can I run analyze on the slave and then make use of that result on the master machine if I were to have some sort of replication chain, for example?
Yeah, sure. That's definitely possible. MySQL.column_stats, the table which holds the histogram, is it is for the most part a regular table. You can insert data there, update the data there, then flash status. There may be one caveat that the tables in MySQL database use special locking rules. So if you try to run insert into MySQL.column_stats select from some other table, you may encounter an error where it doesn't let you that, and there is some error complaining about locking strategies. You can easily work that around, but saving, say, the contents that you need to insert into temporary table or into user variable. But otherwise, you can just update the table, flash tables, and the new statistics will be used after that.
All right, that sounds like a very useful thing to have. Now, I think we have time for one more question. So another practical question is, do I have to decide on my own about the histogram size? And if I do, how big should I make it?
Well, I had a slide, and this is actually the question that I asked it myself, and I had a slide about histogram sizes in other databases. And my current impression is that, like in the the number of buckets should be in the order of 100, maybe 100, maybe 200, or somewhere in that ballpark. This should be sufficient to get the precision that you might expect from a histogram in most cases.
Okay, because it's basically one bucket. The number of buckets is in how many chunks you split all the rows of the table, effectively.
Right.
Okay. Well, that was very informative. Thank you very much, Sergey, for the Q&A. Very good talk, and I hope to have a good interaction with the audience in Zulip as well.
Yeah.
Thank you.
Thank you too.
Hello everyone, Federico here, and I will talk to you about some MariaDB features that should be useful for a lot of DevOps. So who am I? I'm Federico Razzoli, I'm the founder of Retraining. We work with databases, we do consulting, and we are specialized in automation. So a few words about this talk before beginning. The talk is not an overview of all MariaDB features and is not a MariaDB DevOps tutorial. I will not teach you how to deploy MariaDB or take a backup. It's not a list of well-known features or features that, in my opinion, are well-known. It is a list of features that you should know about if you are a DevOps or if you are a DBA or a developer or anything else and you care about automation. Okay, so I use the word DevOps because it's trendy, of course, and because if you know what it means, well, you will agree with me that it's about automation. There is not much time for details, so I will very quickly show the features I want to talk about, and then I really encourage you to check the documentation, find out more, and find out all the possible caveats that possibly I didn't talk about. So, first of all, should DevOps care about SQL and should they care about MariaDB very specific features? Well, when you work with databases, SQL is the native way to do things. Okay, you may prefer to have, layers of abstractions, tools working for you and generating the SQL in a transparent way. But in that way, you don't have much control about the details. And also, these tools tend to do things in a non-optimal way. And they hide all the features they don't know about. Okay. So basically, if you really want to do something optimal and know the details about what you are doing, you should use SQL. Not necessarily always, but at least in some cases. So let's talk about the first feature I wanted to show that actually may be well known or maybe not, I'm not totally sure. And it's the statements show and show create. So show statements allow you to show databases. Schemas are just a synonym for databases in MariaDB. You may be disappointed if you come from certain other databases, but actually I think that this is very practical. Or you can show tables or even columns or indexes or many other database objects. Okay, these are not all the show statements. There are lots of more statements. Check the documentation, but I will focus on these things. This is a very quick and very simple example. This is what you get if you run something like show databases. Show statements are not completely consistent with each other, but they may have a from clause and a like clause or a where clause. So for example, in the case of show tables, as you can see, well, typically you show the tables from the databases you previously selected. Okay, as it happens in the second example. In the first example, I show that you can show tables from a specific database. You can use a like clause, so basically you apply a pattern. Okay, you get the tables that match a certain pattern. In this case, I'm asking for the tables with the prefix WP. In the second example, I show that, well, like is useful, but not always enough, so you can use a proper where clause. And in this case, I'm doing the opposite. I'm looking for the tables that don't have that prefix. Then we can see that we have the show create statements. Okay, so what I do is to get the SQL statement that is needed to create that database or that table or that view and so on. In the case of a table, of course, you will get an empty table. Okay, so you can see the example here. I run show create table, database name, table name, and then I get a create table statement. And this is very useful for a lot of reasons, including a form of backup of table structures and moving tables around. Here you can see a simple example written in pseudocode. It probably took 1 minute or so. So just to show you, what it does is to show the databases, show the tables inside those databases. If tables match certain conditions, you run show create trigger, and then you get the create trigger, and you basically save it into a file. So this shows that it's very quick to do things like, I don't know, there are triggers in staging that solve some kind of problem, and I want to copy them into production. And yeah. So let's see how to copy a table in SQL. I've shown you 2 ways to do it here. In the first case, we run create table like to get an empty copy of the table. Okay, so it's the equivalent of running show create table and then run the statement you get. And then you can run insert select. Okay, so insert into new table name, select from old table name. This is the most flexible way because you can, of course, choose to only select some columns, or you can specify a where clause to only get certain rows, not all of them. Okay. Well, this is useful, for example, if you want to create a copy with just very few rows for testing. Or you can just run create table select that basically copies both the structure and the rows of a table. So in this example, I show that you can do this to create what is usually called a summary table, which means, well, maybe you have a query that takes time. It's complex, maybe. So you can create a table just to store its results, and then instead of running the query again, you will check this summary table. It's useful if the underlying data don't change often, or if they change but you don't care too much about the latest data. Okay? Maybe they are historical data, maybe you are just doing some statistical analysis. Okay? All these things become more interesting if you know about Connect. Connect is a MariaDB only storage engine, which basically allows you to create a local table which works with remote data. Well, actually, it does a lot of things. But one of the things is to connect a remote MySQL or MariaDB server. Not necessarily. It can actually connect to any database if they support ODBC or JDBC. And anyway, you basically write into a remote table or read from a remote table as if it were local. The only difference you will notice, possibly, is performance, of course, right? So here I've shown an example where I basically use connect to create a local table which connects to a remote table, and then I use insert select to get the data from the connect local table and insert them into another regular table. Okay. Why? Because in this way I will have all the data locally. I'm a fan of doing this kind of things because there is not much round trip, right? You just read the data from another server and transfer all data to the local server. I don't create a backup, I don't have to copy the backup elsewhere, I don't have to restore the backup into a different server. So copying a table in SQL, in my opinion, is always better, and copying remote data with connect is often great. Let's see about this nice syntax. Basically, create and drop statements have these clauses. I can run something like create or replace table. So I'm telling, okay, Miss MariaDB, please create this table. If a table with the same name already exists, trash it, destroy it, and recreate it in the way I'm specifying. Or you can use create table if not exists, which is the opposite. So I'm saying, Miss MariaDB, please create this table, but only if it doesn't already exist. If it exists, don't fail with an error because it's expected. Just produce a warning so the script execution can continue. For drop, I can do, for example, drop table if exists. Okay, so if the table actually exists, drop it. Otherwise, doesn't matter. Just produce a warning and don't fail. These statements exist more or less for all the create and drop statements. Then we have alter table. First of all, why is this useful? This is useful for working with database upgrades. Okay, maybe we have several versions of one database. We don't know if a certain server has version 1 or version 2 or version 3. Whatever it has, we want to make some changes, make the desired changes to the database. So I can use alter table to do things like, okay, alter this table, adding this column unless it already exists. But if exists, well, maybe it has a wrong type. So I can also say, change this column if it exists, okay? And then I can do the same with drop column, index, drop index, and actually alter table has many more options, so check the documentation, please. You also have alter table if exists, which is probably less useful. I mean, it can be useful in trivial cases only. Then we have something called, well, we have stored procedures and something called begin not atomic. Okay, of course, there is no time to teach about stored procedures here, right? In case you don't know what they are an extension of SQL language, okay? Instead of only having things like select, insert, update, you have procedural programming. You can use if, you can use loops, and so on. One advantage of stored procedures is that they are incredibly simple. I mean, no matter which programming languages you know, chances are you will be able to understand 90% of stored procedures around. And also they run inside the database. So if they have to do things like copying tables, copying rows, create a new table from the result of a select, well, there will not be any data round trip, right? Data will remain inside the database and will be processed inside the database. Developers don't like them, typically. Actually, you should not abuse them. And actually, in MariaDB, they are slower than they should be. But if you are automating some maintenance task, probably it's a good idea to use stored procedures. I mean, this kind of flows are probably not a problem in that case. It's also worth mentioning that MariaDB implemented PL/SQL, which is basically Oracle language for stored procedures. It's still SQL, but it has many more extensions. Support is not complete, but a lot of stored procedures that work with Oracle will also work with MariaDB. And then I want to mention begin not atomic, which is basically a way to use procedural SQL without creating a stored procedure. So you just put your code in a file, as in this example. You start with begin not atomic, then there is the program, then you put end, and then you pass this file to the MariaDB command line client, and it will run it. So let's talk about rename table and triggers, and yes, they can be related sometimes. You're gonna see why. So one interesting thing with alter table is that you can use it to do what I call a soft drop. Okay, so you have a table called news. You think you can drop it. You think it's not used anymore. You are not 100% sure. You can run rename table instead of drop. Okay, so you are not actually deleting the table and its content. You are just changing the name, and after that, if applications fail with errors, because they are trying to use the news table, you can very quickly change the name again and everything is restored. Okay. The alternative would be to take a backup, which takes time, and that's fine, but then you would drop the table, and then you would get some failures from the application, and then you would have to restore the backup, which is slower, and in the meanwhile applications are still failing. You can also do the same thing with columns and indexes. In the case of a column, the reason is the same. In the case of an index, similar reasons. I mean, recreating an index anyway can take time. It's worth noting that this is actually not necessary anymore for indexes, because now MariaDB has a nice feature called invisible indexes, which I'm not explaining, I'm just quickly mentioning it, so please check the documentation. Two interesting things about the name table are, first of all, you can rename several tables with one statement. So in this example that you can see in blue, I'm doing 3 renames to basically switch 2 table names. Okay, so at the beginning we have A and B. At the end of this statement we will have A and B, which switched names. But it's great to know that this is actually an atomic operation. So in no point in time A doesn't exist or B doesn't exist. So you can do this in production. This has some great use cases for DevOps and DBAs. I'm going to only mention the most obvious one. The most obvious one is when you have to run an alter table, also called migration, in production. Why? Because an alter table could be a heavy operation for a server, but this is another topic, but it can also be a locking operation, meaning that during the operation the table is locked and applications will not be able to write to it. Again, sometimes it's not always true, and more on this later. But suppose that a certain alter table is locking, there is a way to still do it, avoiding locks, provided that you don't have foreign keys. So what you can do is create an empty copy of the table, run the alter table on the empty copy of the table, create triggers to reflect the changes to the original table to the new copy of the table, currently empty. Then start to copy the rows from the original table to the new one. In the meanwhile, applications are still using the original table and they are not noticing anything. When the copy is finished, you can switch the table names. Okay? And applications will suddenly start to use the new version of the table. This is actually what PT Online Schema Change from Percona Toolkit does. So you don't really have to do this manually, but you should know how the tool works. Ghost doesn't do exactly this, but almost the same thing actually, except that Ghost, instead of using triggers, reads the binary log. But I will not explain the details about these tools. So let's talk a bit more about alter table, because you know, it's the typical huge pain in the arse of most DevOps. Sorry for the technical language. So, as we mentioned, PT online schema change is lock-free, actually almost lock-free, but it may imply a lot of data copying. So, if you are running an alter table on a table that is really big, well, you will copy a lot of rows. It will take time, and the server may suffer, and then the applications may suffer. So the good thing is sometimes it's not necessary, because as I mentioned before, it's not always true that alter table is locking. Actually, in the latest versions of MariaDB, the most common operations are usually not locking. This is great, right? Yeah, but things are not always that easy. So, one thing to remember is the exact list of lock-free operations or almost instantaneous operations depends on your MariaDB version. And also, if you have masters and replicas, probably you don't have only one MariaDB version, because you may have, I don't know, MariaDB 10.2 as a master, and then one replica with MariaDB 10.3, and then two replicas with 10.4, and so on. So, there is a great syntax you are seeing now on this slide. If you have only one server with no replicas, this is all you need, actually, almost. But I'm not going to dig into the details. So after this talk, please check the documentation and understand all the caveats I'm not going to mention and all the details I'm not going to mention. But basically, you have an interesting close algorithm and another interesting close lock. Okay, so you can say, okay, Miss MariaDB, do this alter table, but run it as an instant operation with no lock at all. Okay, of course there is no magic behind this, so it's not strange if you will get an error like, what? Are you kidding me? I can't do that. In that case, well, you know that what you asked is not possible. So you will ask a slightly less desirable version of this operation. For example, you may say, okay, then please try to use algorithm no copy, so there is surely no row copying, and use maybe a shared lock. Well, no, probably first you will say use no lock at all. If you get another error, you will try another version. So basically the idea is you can try to have MariaDB doing the alter table in the way you want, and if it's not possible, at least you know what you are doing. To make things more complicated, actually, the no-copy algorithm was introduced in a recent version. So even this command syntax may slightly change. So what will we do if we have a replica chain? Well, we can do what we just talked about, but we can do this one server at a time. So for example, I can, before running the actual alter table, I can run set session SQL log bin equals 0. So the alter table will not be logged to the binary log, so it will not be sent to any replicas. But actually, you should start doing the alter tables from the replicas. Okay, you should start from one replica actually, because if the change you are making creates some disruption, well, you will break only one replica, which hopefully is fine. So once you see that the change succeeded, you can do this on the other replicas, and finally you can do this on a master. Note that when you do so, you should make changes in a compatible way. Okay, so for example, if you are adding a column, you don't want all the insert statements to fail. It would be really bad. I mean, they would fail on the replica only. You will break replication for that particular replica, but still, it's not what you want, right? But if you add a column with a default value, or if you create a nullable column where null is the implicit default, well, this will not break the inserts typically. The last thing I want to mention about alter table is this wonderful syntax, which is no wait or wait followed by a number of seconds. What is the use case? Well, maybe you run an alter table, but a select, a long-running select, maybe it takes hours, is running and is keeping a metadata lock on a table. So basically what happens is the alter table is blocked by the select. It waits until the select ends. You may think this is fine, okay, but select doesn't lock. Well, there are always cases where things are different, but normally a select doesn't lock insert, delete, and update statements, but alter table does. So what will happen is your alter table will wait until select completion, and insert, delete, updates will wait until alter table completions, even if it didn't even start. So if you use alter table no wait, for example, you are saying, okay, Miss MariaDB, run this alter table, but only if you can do it now. If there is a lock on the, if there is a metadata lock on the table, just fail with an error immediately without any wait. Or maybe more realistically, you can specify a number of seconds to wait. So let's talk about binlog format, because this is something that you should really know about, in my opinion. Binlog format is a variable which determines how the changes you are making to the data are written to the binary log. It can have three values: statement, row, or mixed. Statement means what it seems, so it logs the SQL statements. Row logs a binary representation of the changes you are making. So the primary key, or a way to identify a row, and then the new values to change into that row. Typically, row is faster than statement. Typically means almost always. Why? Because with statement, you run a query in the master, and then the query needs to be run again on each replica. With row, the replicas will not have to run the query again. They will immediately know which rows must be changed and which values must be inserted. Mixed is basically use statement whenever you can, but sometimes you can't or shouldn't, because certain SQL statements may have may produce different results on different times or on different servers. They are not deterministic. For example, in case you have an order by in your you have a limit in your statement, like delete from table X, limit 5. Okay, I'm deleting 5 rows, but if I don't have an order by, which rows am I deleting? It's not deterministic, right? In a case like this, row will be used. So, I mentioned that usually row is faster, but sometimes not. Take this query, for example. I'm deleting basically all the rows, right? Actually, the query also has one more feature I didn't mention yet, which is returning. It means it's a delete, but also a select. So I'm deleting these rows, but I'm also getting the rows. So this can be useful for DevOps when they have to archive historical data and move them from MariaDB to somewhere else. But suppose that, yeah, maybe this statement speed is acceptable because it's using an index, but maybe it's deleting millions of rows. And if we are using row, well, it would be better to run one statement instead of looking for millions of rows individually and change them all one by one. Okay, so in this case we want to use statement, but the server is also used by production applications, so we don't want to make the change globally. So we run set session bin log format equal statement. We run our query, it will be logged as a statement, and then we restore the default. User statistics is the last feature I want to talk about. First thing I want to say is it doesn't replace performance schema in any ways. You should have that performance schema enabled in production because it allows you to run some complex analysis that can only be run with performance schema, okay? Like investigating some mutexes in the server and so on. But user statistic is a MariaDB specific feature which gives you basically information about the workload. I should be fair, I said it's MariaDB specific, but it's also in Percona server because it was originally developed by Percona. So you enable it by inserting this option into the configuration file, user stat equal 1. So when you restart MariaDB, it will be enabled. but to enable it even before restart, you run set global user stat1. And then you have some interesting tables. I will only mention two of them. The tables are in the information schema database, which is a system database. And the first table I want to mention is table statistics, which basically has statistics on table usage. So you have, of course, two columns with the database name and the table name, and then you have three important information, which are the number of rows read, number of rows changed, and number of rows changed multiplied by the number of indexes. These numbers are from the last restart, not forever, okay? So if you see 0 somewhere, it doesn't mean that the table was never read. It means that it wasn't read since the last restart. Anyway, you can use this feature to find unused tables that you can probably delete, to find out which tables need optimization, because maybe you can see that a table is written much more often than any other table, so you want to make sure it doesn't have useless indexes, like duplicate indexes or simply unused indexes. And then you can also see if there are spikes. So if you are using a cool monitoring tool with some cool visualization, for example, you can use PMM from Percona, you can see a graph of each table usage, and if you see that the usage of a particular table suddenly increased, it means probably that developers just deployed some change to the application that makes a heavy use of a table. Why am I mentioning this? Well, I can remember some episodes where I seen this as a DBA after we were noticing that the server had problems. So sometimes, yes, sometimes you don't have an easy solution. You have to find out what's happening. Sometimes you have to optimize some queries, but sometimes you quickly see that there is clearly a bug. For example, I remember a real case when developers deployed in production an application which had an infinite loop, which inserted rows into a table forever. And, well, this is the fastest method to notice this kind of stuff. The other interesting table I wanted to mention is index statistics, which shows, well, of course, statistics on index usage. So for each index, you can see how many rows have been read again since the last server restart. Why is it useful? Well, you can see which indexes are not used at all, and you probably want to delete them. And you can see which indexes are mostly used. And in that case, well, if an index is used far more than any other index, you may check if it has too many columns, or the opposite, if it should have more columns to optimize some queries even better. So this was the last feature. Thank you for attending. I hope you enjoyed.
Hello, Federico, and thank you so much for a great presentation on MariaDB features that all DevOps engineers should know. It was really interesting, and I'm really happy to have you here, and now I have a few questions. First, I would like to ask you, do you think that DevOps engineers should administer databases?
Hi, Anna. So, first of all, thank you for the opportunity. I always enjoy to make these presentations for MariaDB ServerFests. So, coming to your question, first of all, some people may get angry, but well, you know, DevOps already manage MariaDB databases and all kind of databases. It's not my fault. I didn't take that decision. If you ask me if they should, well, maybe not, because it's better if databases are managed by people who best know them. And I'm sure that many DevOps will agree with me on that. Many of them didn't choose to manage databases. So yes, DBAs, database administrators, should manage databases. But in my opinion, nowadays they should have a DevOps mentality. What do I mean? Nowadays, you need to automate. It's not like 10 years ago when you had less servers, less different technologies to manage. Well, you have more tasks. You need to make sure to repeat them in the same way every time, and you can do that with automation. And DevOps is about automation after all.
Mm-hmm. All right. And if a DevOps engineer does end up administering databases, what do you think are main problems and challenges they would face?
I think the most common problem is definitely with migrations. I mean, they tend to call migrations, big alter tables on big tables in production, because they are always concerned about, putting some locks on the tables and block the application, and then the application is not able to write, and writes will be queued, and everything will crash. Of course, it's a nightmare. Also, even if they know how to do it, they would like to automate it. They don't like to do it manually every time, and automating it can be difficult. That's an area where you need someone who understands how MariaDB works, how logs works, which solutions you can use. In general, of course, DevOps are comfortable in situations where things are linear, because they don't know the complex problems related to, some MariaDB details or something that happens under the hood. Ideally, the best situation is when you can read a manual page and then just write a procedure that does exactly what is described in the page. Situations where these may not apply is, for example, upgrades. If you want to upgrade a server in production, especially if you want to upgrade a node in a cluster without having a downtime for the whole cluster. I would say that the two things I mentioned are the main problems they have. And they can solve them with more specialized professionals who understand MariaDB or whatever they're using.
Well, as far as migration is concerned, I hope you would have time to watch Monty's presentations that we have at this ServerFest. It's called The Curious Case of a Disappearing Commercial Database. And actually, he is doing this kind of Agatha Christie story on migration process, how people come to MariaDB. So do have a look. It might be useful, I think. And final question to you is that you are practically a veteran of our MariaDB ServerFest. You've been doing all kinds of great presentations for us. And in particular, you were talking about automating MariaDB with Ansible. So now you are talking about native SQL features. And I'm wondering, what do you say now? Should Ansible be used or not?
Well, yes, Ansible should be used. If not Ansible, some alternative that you may prefer. I mean, someone could choose to use Puppet or Chef or Salt, and that's fine. But the idea is use some automation software of that type, but don't necessarily use it at the highest level. I mean, Ansible, for example, has a lot of modules, like, for example, I don't know, MySQL database, and you could use it. But what is the benefit? I mean, you can also write your queries. Sometimes it's even simpler. Of course, the drawback is if you use the modules, you will use Ansible in an idempotent way, which is the purpose of Ansible, which is part of the purpose of Ansible. And yes, but sometimes all you have to do to be idempotent is just to ignore errors in case you get them. So definitely understand SQL, use it whenever it gives you more power or whenever it eliminates, uncertainty, because sometimes it's not 100% clear what will happen if you tell a certain module to do something. You will not know which queries it will run in details. Okay. So yeah, use a combination of both. And the question may become slightly more complex in the case of startups that currently don't have any automation in place. And they will say, oh, yes, but implementing, some Ansible infrastructure may be complex, especially for us because we don't have the specific skills. And then my advice is, okay, build that skill with time, and in the meanwhile, start to automate in some trivial way. Start by simply building, I don't know, some simple Bash or Python scripts doing stuff. And then when those scripts are not enough anymore, you will turn them into Ansible playbooks.
Okay, thank you so much, Federica. It was really interesting, and I hope we can do it again in our December ServerFest. But thank you for now.
Hello, welcome all. Today we are going to talk about scaling MariaDB on ARM. We all know MariaDB scale well on ARM. In past, multiple patches has been contributed by community and that has helped or allowed MariaDB to scale well on ARM. The trend continues and this year too, multiple or more patches were contributed that allowed MariaDB to scale even better on ARM. Especially with multiple NUMA nodes, MariaDB has started touching a QPS of 1.7 billion with 4 NUMA nodes. And things are further improving. So we'll look at what is the state of current MariaDB ecosystem on ARM, and then we'll talk about what all patches or what all improvements has been contributed and how it is allowing to scale MariaDB on ARM. So let's get started. My name is Cardinality. I have been driving this DB on ARM initiative. That's quick intro about me. I have been working in MySQL space for more than a decade now. Currently, I'm working with Huawei as part of DB on ARM initiative. In past, I've worked with Percona, MySQL Oracle, Yahoo Labs, and more organizations. I do blog and I do present at most of the leading MySQL conferences too. So with that note, let's talk about today's agenda. So first, we'll try to understand ARM and databases. Then we'll talk about state of MariaDB ecosystem on ARM. And then we'll talk about what has scaled MariaDB on ARM, and we'll end it with a note on future direction. So the ARM processors are getting quite good popularity for running databases. So what exactly has fueled this out is ARM processor has more core, in turns more parallelism. Most of the database server are able to use this extra parallel cores or extra compute power to perform a lot of parallel operations and produce better throughput. Beyond that, ARM cores are also powerful. Traditionally, ARM processors were used for cell phones and those kind of applications. So, user probably thought that ARM processor may not be that powerful, but ARM processors has proved themselves to be one of the best fit for running high performance computing applications, including databases. They are next-gen cloud processors with security inbuilt. In upcoming new versions, there will be a inbuilt security things coming up, SoC kind of things. The growing SIMD set, which allows you to do a lot of parallel operations and help you in getting better parallel throughput. ARM processor continue to add more and more hardware functions for critical function, operations which are compute intensive, like checksum, cryptography, and all. So overall, with all that things in place, and of course the price performance, ARM processor become one of the best fit for running databases. As beyond that added advantage, if you look at your complete ecosystem, right from where you capture the data to where you process the data to where you store the data, could be completely migrated to ARM. There is a growing developer interest, and the open license model that ARM follows allows multiple vendors to innovate over and above the base thing, and that actually has set up a good fast-paced improvement all over the industry. Let's understand this more with some of the examples. So it is expected that in next few years, 25% of HPC market share will be taken over by ARM, and majority of it will be driven or led by database or its supporting component. That is huge amount of market share, to capture. Now, from a user perspective, user could get a potential 50% saving for the same or better throughput. If you talk about databases, most of the open source databases is already ported on ARM, and it is not only limited to single type of database like OLTP or so. Database from all category, whether it's NoSQL database, OLAP database, all of them have been ported or in process of getting ported to ARM. And this is an interesting fact. In last year, that is 2020, 49% of the new instances that were booted on AWS were ARM instances. So that all shows up how popular ARM is getting and how users are trying to evaluate or start using ARM. In upcoming days, we plan to see a lot more databases being run on ARM. So majority of the leading database already have started providing packages for ARM, and DB on ARM initiative is gaining quite good traction, with majority of users are either showing interest or already started running or evaluating the databases on ARM. With that note, let's talk about state of MariaDB ecosystem on ARM. So MariaDB has been offering packages for MariaDB server on ARM for quite some time. All the features are supported, like bin log replication, HA compression. So it is a full-fledged package which you could use in production kind of environment. If you talk about ecosystem, continuous efforts are being made to make sure that all the components are made available on ARM. In fact, all the main components that a user need to run a complete ecosystem, a full stack ecosystem on ARM is already there, but additional components or multiple options are getting added. Let's understand this with an example. So we all know MariaDB server is already available on ARM. But database doesn't operate in standalone fashion. There are a lot of supporting components, like there's a backup component, HS solution, load balancer, monitoring, connectors, DB tools. As we could see, there is at least 1 to 2 components, and more could be there. I've just considered some representative and popular components or tools. They are available on ARM. So if a user wants to run a full stack ecosystem on ARM using all open source tools, then that is possible. If we talk about performance, so already we know MariaDB scale well on ARM, and the efforts continues. More and more new patches are getting added. This year also some new patches got added. And as I said, we had we could see that with 4 NUMA node, MariaDB server was able to touch a QPS of 1.7 million. Let's understand with some examples of how MariaDB is performing against its counterpart. So here we have used a cost performance model. In cost performance model, we continue to keep the cost same and allow the compute resources to vary. ARM being cheaper, get more compute resources compared to its counterpart. Now MariaDB server is able to use these extra resources and produce a better throughput with increasing scalability. In fact, in some cases, the difference is almost 2x. So that could show that you could get more TPS for same cost. So this is with uniform CPU bound. If you have a use case which has ZPN kind of things, which is more contention based use case, CPU bound, again we could see MariaDB on ARM is able to scale better as compared to its counterpart. If we have something like IO bound use case, because majority of the setups, production setups may have IO bound use case with part of the data not available in memory. So in that case, IO also becomes important, and in that case also MariaDB on ARM is able to scale well, and as you could see in most of the cases there is a significant difference that is observed between MariaDB on ARM and its counterpart. So the message is very clear, you could get more TPS for the same cost. If you are talking about uniform CPU bound, now here we considered another use case just to understand are ARM processor powerful enough. So instead of using the cost performance model, we use compute constant model. So here we continue to provide same compute resources to both the variant ARM and x86 and try comparing the performance. ARM is cheaper, so it is coming at 50% lesser cost. But let's keep the cost aside and let's understand with same amount of resources how does ARM performs. So here also we could see MariaDB on ARM is performing on par and in some cases better than its counterpart. Please note that ARM is running at 2.6 GHz and x86 is running at 3 GHz. So you could get same performance for lesser cost. So either you could get more TPS for same cost or you can get same performance for lesser cost. So that shows up that ARM processors is quite powerful, and running MariaDB on ARM could be one of the alternative good choice that you could consider for production environment too. Now, as far as being open source database, community contribution or how presence of community is there is also important. So there is a pretty good strong community support. Already users have started reporting bugs or issues, and MariaDB team along with community has already resolved most of these issues and continue to resolve the issues as and when they come up. And beyond that also, MariaDB team continue to make efforts to make sure that all of their releases or all of their small enhancements are being tested on ARM before they are folded to the trunk. There is a dedicated channel where all these developments are discussed. On Zulip chat, there is a channel called as MariaDB on ARM. You can always tune to it and figure out what are the new development happening in MariaDB on ARM. So with all that, what we could summarize is that MariaDB on ARM is quite ready, and if one user want to try running the setup or just migrate the setup from existing thing to ARM, then I think there shouldn't be any issue. It is production ready, all the components or all the important aspects are being taken care of. So with that, now let's understand what has allowed MariaDB to scale well on ARM. So first is NUMA scalability. So before we get into it, let's first understand what is NUMA scalability. It is expected that with more resources given to a program, it is supposed to perform better. Now in this case, on left hand side, we could see we are trying to increment a global counter. Here we have kept the scalability same, and in spite of giving more compute resources, in case of 1 NUMA to 2 NUMA and 2 to 4 NUMA, the resources are getting double compute resources. Despite of that, we could see the operations per seconds are reducing. If you talk about spin loop kind of things, which is more like a mutex thing, we could see the contention is supposed to reduce with increasing number of compute resources, but from 1 NUMA to 2 NUMA there was a slight reduction, but moment we went from 2 NUMA to 4 NUMA there was increased contention. Okay, so what exactly is happening here is, instead of reducing, or the contention getting reducing, or performance getting better, the performance is getting worse with increasing NUMA. So that is what we call as NUMA scalability. Let's understand this with practical example. When we started evaluating MariaDB server for NUMA issues, so this is with a point select or read-only workload, we found out when we move from 1 NUMA to 2 NUMA, there was linear scalability. But the moment we move from 2 NUMA to 4 NUMA, the performance was reduced. There was regression. It was not even same. In fact, it was supposed to get better because more resources were provided, but there was a regression. So when we started investigating, we found out that one of the culprit was global counter. There is a global counter which was used or which is incremented whenever a page is accessed, and this global counter was getting accessed and acting as point of contention. So the solution was to move it from a normal global counter to a sharded global counter, where a counter is now divided into n shard. Every core is supposed to update its own shard, and the aggregate value of all the shards will represent that counter. The other problem we found out is that there was a global Dixis mutex that was getting used, and now imagine that all the cores trying to access this particular mutex, the amount of contention this particular mutex will create. So of course the solution was to move to a table level mutex. So we moved to a table level mutex, and with both of these things we figured out that the thing started to scale linearly. So as you could see, almost a linear scalability is observed when we moved from 2 NUMA to 4 NUMA 2, and with that we were able to touch a QPS of 1.6 million. Now this is with read-only workload. So even read-only workload, the performance improved. With read-only workload, the performance from 2 to 4 NUMA was not that bad. There was no regression, but still it was not linearly scaling. When we fixed this out, you could see almost a linear scalability was observed with read-only workload. In terms of numbers, if you talk about, we got a pretty good improvement, 1.6x improvement in point select use case and 1.25x improvement in read-only use case. So one important point I would like to mention is a function signature in perf could show up 1 to 2%, but if that function or that particular counter is falling into critical path, solving it and removing that 1% could have a huge impact on the overall performance, because the weight graph or timing graph is quite different, and especially with NUMA it is quite different. So you should not ignore these even small functions which will may get reported with a signature of 1 to 2% in perf. There was another such counter which was used to track whether the query got serviced through AHI, that is adaptive hash index, or through a non-AHI. So this particular counter was again a global counter. Using the same technique, we moved it to use distributed counter, and we figured out that with that we got an 8% improvement in that case. Now, can we move all the counter to distributed counter? And of course no, because distributed counters are costly. They consume a lot of memory. So you have to carefully examine and figure out which counters are in the critical path and only move those counters to use distributed counters. What about write workload? So write workload, there is still some issues, as you could see when we move from 1 to 2 NUMA, while the performance is slightly decreased, but the moment we move from 2 to 4 NUMA, the performance is almost 50% below it. So there is a 50% regression that we could see. And when we did some analysis, we figured out that Loxis mutex is quite hot, and weight per thread in 1 NUMA case is 1.2 and weight per thread in 4 NUMA case is 2.7. So it is almost 2.5x times when we compare with 1 NUMA to 4 NUMA. So with that NUMA scalability issues, now let's move on to another thing, which is spin loop optimization. So spin loop is something which has been, could have significant impact, and making sure that they are tuned properly and enough latency is introduced is very important. Now with x86 there is a pause instruction, but here we don't have exact pause instruction. There is yield, but how it is implemented, it could be no op in some processor. So making sure that a proper latency or proper wait is introduced is very important. So multiple variant were tried, right from using the cache-based variant, then to use a memory barrier, and then improving on the memory barriers and all these things were tried. And I see this particular thing continue. We continue to work on it, tune it, making sure it is optimal. But you could see that there could be a difference, that 10.4 may have a different version of spin loop versus 10.5 may have different version, because based on the timing model, maybe a lesser latency is needed. So we continue to benchmark it from version to version and make sure that with whatever is the best version suited of spin loop is used. Now, lately, even MariaDB team has divided mutexes into mutexes that need spin loops and mutexes that doesn't probably need spin loop, and that seems to also further help in this particular efforts. Purge optimization. So purge is very super important because it is happening in background, and it can actually if not done properly, as in not scheduled properly, it could actually affect your user visible workload. So there are two aspects there. One was to skip the purge check for read-only workload, because there was no need for read-only workload to check for this, and of course avoiding or overdoing the purge. So let's understand what these two problems are. So on every transaction commit, there was a check that was invoked to check if there was a change in the RSEC history length. And if there is a change, then the purge will get invoked or will get signaled. Now, if you are operating a pure read-only workload, there will be no change in RSEC history length. So there was no point in doing this check. Now, that doesn't sound to be a bigger issue though. But imagine now this particular check was to go ahead and find out the aggregate value of RSEC history length, which was coming up from 128 rollback segments RSEC history length. So it was more like you are, in the same way, assume it to be a distributed counter, and every time a transaction commit is done, all these 128 global variables are read to find out the aggregate value. Now this becomes an issue if every core on every transaction commit is supposed to calculate this and then take a decision. Now that shows up in the perf with a signature of 0.91%. So, and especially with NUMA or multi-NUMA access, the cache length become pretty hot and it acts as a contention. So when this particular issue was solved, now of course the original patch was to skip this for read-only workload, but eventually MariaDB team further improved it to make sure that the purge doesn't get checked in transaction commit. Purge scheduling is done through a separate background thread. So we could see an improvement of 2 to 3%. Okay, so that is the change. What I was talking about is simple improvement, which may show up like it was the signature was less than 1%, but it potentially generated an improvement of 3% because of the weight graph that changes and the effect it has on the NUMA things. This is another problem which we started facing. So we all know purge causes redo logs to get generated. So when purge is actively happening in background and there is a user workload also actively functioning, then both of these things could put pressure on the redo log, and that will generate a few a redo log. If size is being hit, then could cause a furious flushing to start happening. 1, 2, which is that with this particular thing, your user workload will start to show jitter in the performance. Also, how purge thread gets scheduled could be different from one processor to other processor, including the same ARM processors, but based on different vendors of how it's getting scheduled, what different kernel you are using and all. So predictable performance is difficult. So when we started testing it, this is with the default purge thread equal to 4, we started observing that there is a lot of jitter. The blue line shows the TPS, and there's a lot of jitter in the performance. There are times when performance hits 0. So that was, of course, that was not expected, or that is something bad from end user perspective. Beyond that, you could see that the average TPS is around 10K or so. And of course, the history length continue to keep on rise, and with aggressive purge, it continues to fall back. So history length is kept in the check in that sense. So we proposed an adaptive purge algorithm. So this particular algorithm or patch is still under review. Hopefully by the time you go for the conference, it might get accepted or so. But let's understand what this particular thing did. So with adaptive purge, as and when there is a redo log size, or basically redo log continue to fill out, then we continue to throttle the purge by reducing the number of the purge thread that gets scheduled. By default, currently, if you have configured for 4 purge thread, all 4 purge thread will get scheduled, which means a purge is happening at very aggressive rate. But what we now do, or basically the patch does, is try to monitor the redo log size. If redo log size is increasing, then it will try to throttle the purge by reducing the purge thread which are being used. So this has 2 important advantages. One, of course, now redo space, the workload, user workload is getting priority. So there is a reduction in jitter. Second, since logsys mutex was the hottest mutex that we saw, now that logsys mutex, pressure on logsys mutex is reduced because of the throttling of purge, it allowed the overall throughput to improve from 10K to 55K. So I think that itself explains that less jitter and almost 5x improvement in throughput is what you could get by moving to an adaptive purge. Now, of course, on the flip side, there is increase in the history length. But as you could see, whenever there is a gap, in this case, after 300 seconds, we introduce a gap or a sleep of 20 seconds in the workload, and purge quickly, or the history length steeply reduces in that particular time frame. So wherever there is a gap, the purge will make sure that the history length continuously follow, and again when the redo log size reduces, the purge thread will again become aggressive. So that's how the adaptive purge works. So to understand it better, so here we are assuming that purge thread is equal to 4. So in this case, the algorithm will not kick in till we cross the LWM, that is lower watermark. Once we cross this LWM, the algorithm will kick in, and since we are talking about 4 purge thread, you could see 4 buckets. Red, yellow, green and orange, and when the redo log is in the range of red bucket, then 4 purge thread will be used. When it moves to yellow bucket, 3 purge thread will be used, and when it moves to green bucket, 2, and then when it goes to orange, 1 purge thread will be used. Moment it crossed the higher watermark, purge thread will continue to happen. It will be equal to 1, but extra delay will be introduced so that there is no back-to-back purge scheduling. So with that particular change, as we could see, we got a better throughput and lesser jitter. And of course, since we considered for 4 buckets, 4 threads, there are 4 buckets. So the algorithm is auto-adjusting. If you have 8 threads, or you have 6 threads, or you have 32 threads, that's max allowed, it will configure these buckets or ranges accordingly. So with that, let's talk about flushing. So with most of the compute related things taken care of, we started to concentrate on IO bound workloads. So when we started working on it, we started first hitting multiple roadblocks, and which were related to some tail issues like ideal flushing, which was originally there, but during the revamp probably got removed, and the ideal flushing got missing. So ideal flushing is nothing but when you have when your server is ideal, and even if you have some dirty pages which are less than the lower watermark which you have configured, still server should go ahead and continue to flush those pages, making sure that the buffer pool is clean and the dirty count is dropped to 0. Same way, there is the adaptive flushing was not getting kicked in after crossing the threshold. And on the same line, when redo log started to fill out or cross some certain threshold, then that point also adaptive flushing should kick in. So all of these things were missing. So we contributed patches for it so that the general performance gets stabilized. And even after all these patches, there we still continue to see there was a jitter in performance. So we initially started blaming IO capacity. Since we were using smaller IO capacity, we thought we have a good disk of which could support 120K sequential write and 70K random writes. So why not give the complete capacity or configure it to use complete capacity and get better throughput? But shortly, so this probably is something which we all are aware of, but may get ignored. The double rate buffer eats 50% of your IOPS. So make sure that you, even if you reserve IOPS, especially with cloud setup, let's say you reserve IOPS 50K, 25K is what you will effectively get, because 25K will go to double rate buffer. Now let's assume that you have 24K IOPS and 12K is what effective IOPS you get, and that 12K and page cleaner thread need 1 second as a latency for flushing these 12K pages. Effectively 24K pages are getting flushed. The flush list mutex there will be huge contention of flush list mutex, which could cause user thread to get blocked from adding the pages that they are making dirty to the flush list. So a right balance between the IO capacity and how much pages to be flushed has to be achieved. So we started experimenting. So we tried with a simple thing, 2K, 4K, which is the smallest thing. Of course, initially it gave us some good performance, and then the moment furious flashing started, the performance dropped down to almost 0. So then we improved it to 1224K, and that's when we observed that with 12 and 24K, the performance continue to get better, but there were series or time when furious flushing continued to pull it down, and till that particular phase is done, the performance continued to remain low. Then we tried to put it to the maximum, that is 120K, and there, as you could see, this was kind of not expected. There was a lot of jitter that got introduced. Of course, performance didn't improve, but there was a lot of jitter, and the phase of when performance goes down continued. So we further analyzed it, and what we discovered is we were concentrating completely on page flushing. While being an IO workload, the LRU flushing also plays an important role. And LRU flushing is not dependent or doesn't honor the InnoDB IO capacity or InnoDB IO capacity max kind of parameters. That is made for page flushing, or the what we call as flush list flushing. So LRU flushing is the only flushing which will generate free pages. So making sure that you tune LRU flushing properly in IO-bound workload is super important. So what was the problem is whenever a LRU flushing happens, there was this particular thing, InnoDB LRU flush size variable, which controlled how many pages will get flushed in the background. So while that was good, but the issue was like the default value was 32. Now if you are operating with a higher scalability of 512 threads, then these 32 threads will immediately get consumed. So that means almost every in the threads, maybe every alternate thread will have to go ahead and do LRU flushing, and that means the latency of that thread will further increase. So when we started experimenting with the values, what we figured out is 4 times the scalability. So if you are operating with a scalability of 512 threads, what we observed is 4 times the scalability is 2048. If you set this value to 2048, you will get a better and stable performance. As you could see in this case, with 2048 and using the capacity, IO capacity to 12 and max capacity to 24, we got better and stable performance. Not only the performance base value or overall throughput improved, it was quite stable. So with that tune, we actually achieved multiple things. Now we didn't exhaust the IOPS limits because we are using only 1224. So we are leaving open good amount of space for allowing LRU to get flushed also. And we are not contending on the flush list mutex also. So that is how we got a better throughput. Now, very important thing to note is that when you configure LRU flush size, make sure that your LRU scan depth, that is another variable, is more or higher than LRU flush size, because otherwise algorithm will start short circuit itself based on once they hit the target of LRU scan depth. Now, of course, I have a detailed blog on my blogging site about how to configure it and what effect it has, but make sure that you observe this particular variable. So more things are coming in pipeline. We are already working on something called as element per latch. We've already contributed a patch for it. Element per latch is for every n pages there is one latch. Now this n pages or n value is configured based on cache line. If you have wider cache line like we have in ARM 128, so 15 pages we have one latch, and in x86 or small machines which have 64 byte cache line, 7 pages we have one latch. So that could show that we have more contention originating because we have 15 pages controlled by one latch. So we have proposed a patch there. Then playing with GCC, LSC optimizations or atomic optimizations, playing with different optimizations mode, trying to use SIMD for parallel operation, especially like character set mapping and all. So with that, we come down to end of our presentation. So before we start taking questions, if in case you have further questions, you can always write back to me. We have a blog. You can actually go ahead and visit blog. We write, there are quite good articles, especially about MariaDB scalability, MySQL scalability. There are channels where you could post your questions also, MySQL on ARM, MariaDB on ARM. And of course, I do tweet. That's my tweet handle. So you can always follow me and figure out what's happening in the ARM or MariaDB or MySQL on ARM world. So thanks for attending, and we'll now open the session for any questions you have. Thank you.
Hello everybody, my name's Richard and I work at MariaDB. Specifically, I'm a software engineer on the monitoring team at SkySQL. And recently I've been asking that question myself again. I'm torturing myself with that question again. Why NoSQL? Why NoSQL? And I think various reasons kind of come at you. So maybe you do have a specific data set problem. Maybe there's something out there that fits your data need. But I wasn't too convinced about that. There must be other reasons. Maybe you're into memes. You follow the meme. NoSQL scales. Of course it is. It's web scale. Maybe you've been looking at what other people have been doing and seeing what they're interested in, seeing where the trends are laying or going. Maybe you prefer your technological discussions and technological requirements and recommendations to come from needlessly nested arguments and comment threads on social media. Or maybe you take your tech recommendations through interpreted dance. If you do that, this talk is definitely for you. I will do no dancing. I promise you that. Maybe on another video. So I thought, for why NoSQL, it's good to have an example project. And for those of you familiar with Pygame or the Raspberry Pi ecosystem, may have seen this before. And it's a project called Code the Classics. And if you've ever done any sort of programming before, and perhaps an exercise you've done is to recreate an existing tool like grep or cat inside your new language of choice or something new you're learning, it's quite a common exercise. This is instead having a go at making old classics like Space Invaders and these old kind of games. And I thought, yeah, I could do that. Let's have a little play with that. And I got to a point where I thought, well, this game code is quite complex, but they all have something in common. I'm sure some of you may have remembering typing in your three-lettered names or initials in arcade machines when you've wanted to record your high score. It's very important. You must be known for alternity that this is your high score in Mortal Kombat 2 on the pub arcade machine. I also thought, well, I'd quite like to record my high score in some of these old games. And I'll give you an example of that in a second. And in fact, let's have a quick look at some of the code. Let's go. So there's a few games in here. One was like a Space Invaders, one was like a Bubble Bobble, if anyone remembers these things. But this one was a little simpler because the death loop was quicker and I could fail quicker, which helps the example today. It's called Bunner, and I'll show it to you in example in a second. I thought, well, this game code is actually pretty complex. Do I really want to be importing SQL Alchemy or writing a Django backend? I just want to write the high score to some kind of database somewhere, but I'm not going to use any of this complex, messy SQL stuff. I can't do that. This is complex enough. Surely I can't add anything like that. So I thought, I know what will be easier than learning SQL using a database. I'm going to write my own database, specifically a key value database, and I've called it KVDB. It's been around for a little while, and I've used it in a few home projects here and there. But if you want to learn something, we can just write something from scratch. So no peeking in the meantime. I'll take you through what's happening next. So what is KVDB? Let's have a look. First of all, or rather, how have I implemented it? What have I done with it? Well, I import my little library, KVDB. So I just added in like a few lines of code to this already very complex game. And in fact, I'll give you a quick demo of the game first. Maybe this will give a bit more insight. Python 3, Bunner. Let's run it. There we go. Oh, there we go. And this is great. And I have to get the little bunny rabbit across the road. And I got a score of 4. Okay, I'll try that again. Okay, I can't tell you how many times I've watched this poor rabbit die. Okay, 3. Okay, I've got a high score of 95, it seems, which is in the top right-hand corner. I've got no idea how I did that. Okay, always watch for trains, left and right, kids. Okay, so that's an example of the game. So there's a score and there's a high score. I'd like to record that. And in this implementation, I'm adding 2 lines of code. Can you believe this? 2 lines of code to my database. to my game, and I'm now storing these things inside the database, and I'll prove it to you as well inside my very own key value database. So db equals kv.db, and I've in KVDB I have collections, and this collection is called game scores. And if I just look for db.put, one command. When I get to the game over state, db.put, I call the key bunner, because that's the name of the game, and in a dictionary, Python dictionary, score, game.score. And I've got a score. Let's have a see. Let's see what that looks like. I've got a REPL open, and I've done exactly the same statements over here. I've imported KVDB, db equals KVDB game stores, and then if I do a db.get, there's my high score in the database. I did it. I've recorded my score. It's not a high score, but it's a score. Let's try that again. Let's run the game again. Let's see if I can get a higher score than 6 for this example. This is where the pressure really comes. Like, can I get a score higher than 6? Oh my word. Are the logs on my side today? Oh, 11. That'll do. Off you go. Yeah, game over. I've seen that game over screen far too many times this week. Let's have a look. Let's do a db.get. 13. Did I get 13? I thought I got 11. Maybe I was a bit too quick to quit it. I'll do that again, actually. I'm not convinced by that. Am I just adding scores somewhere? Am I going to become the new King Kong champion by just injecting my own code somewhere? Donkey Kong. 23. Oh. Roads are very dangerous. 23. Yeah, I must have just been too hasty. All that code and coffee. Oh, that's very cold. But this isn't that good, because in my key value database I keep overwriting the same key with just my current score, so that's not very good. I did come up with this very simple solution. So the problem here is I'm overwriting the same key with the same score. So a little simple solution. I started to, let's go to the top of the file, generate a string UUID, just using the UUID library. If I go back to that line, which is at 956, I'll create a game key, which is unique. So the name of the game, and then maybe my unique key as well. See if this looks game ID. See how that looks. Oops. Oh, not now. Oh, please go away. Let's try running that and let's see what happens now. Okay. So I had a unique key before, and now this should have a separate session ID. Or 14, I think. Not too bad. Let's try dbget again. There we go. I now have 2 key value entries, bunner and bunner with this string ID. Not too bad. And I can keep adding on to the keys as well. If I was using the old key, let's record a high score as well. So then I can see at the time what the high score was if a current high score. See, this is the beauty of a key value database. Why NoSQL? Because it's so easy. It's so easy. I don't have to do anything. I'm just going to add high score now. No messy tables or SQL. God. Oh, I need to run the game again. There we go. Oh, 4. Yes, I did not hit this, but I know the high score is 95. So let's see how that got. There we go. So now I've got an extra key in here, and and another key value within my keys. Within my key values, I've got key values, which are of course Python dictionaries within Python dictionaries within Python dictionaries. Brilliant database design. I'm so glad I didn't jump into that messy database stuff which people keep telling me all about. No SQL is the future. Look, no SQL at all, and now I can just write what I want to where I want. So I've got current high score 95. Fantastic. I can also let's have a so that's quite easy. I've got 2 lines inside the file, and I can also like play around with unique keys and things, and I can update scores. In fact, if now I've had that unique key, what if I started overwriting the old key as well? Considering I've added these extra fields, so the old key will get updated. So currently it's got a score of 23. I'm just going to append the high score over it. So whatever happens, it will just overwrite that key, because it's simple. It's simple. Let's go for a swim. Perfect. Oh, 11 again. This poor bunny. There we go. So the original key, Bunner, got updated with a score of 11. Current high score, 95. Which is true. I might never touch that 95 again. I think after today, I think I really need to give this rabbit a break. But let's have a look at some of the ingredients that go into KVDB. Let's have a look at this library then. Why did I create this and what's going on? Well, I have the code open. Let's have a little look at it. Oh, this is my library, KVDB. But I'm importing the MariaDB Python connector, or MariaDB connector Python. That's right. It was actually MariaDB the whole time. I mean, I think that would be, and that's what you'd expect. If you're going to join MariaDB ServerFest, I wouldn't start showing you another database. Look at it. I'm using MariaDB and the Python connector. And let's look at some of the magic here. In my init function, init method for the class KVDB, or DB rather, I'm actually creating a table with a JSON type. And this is my infinitely extensible data type, where I could just put everything in and start pushing it off, and without a care in the world. As long as my keys are unique, it doesn't matter. And if I go back to some of these methods I was using, so I was using put, there's a put, so I insert into my KV values, on duplicate, just update the key, nice and easy, take all the pain away from me, and a JSON set function on there as well. And it's worth reading through all the JSON functions. There's lots there. I'll be talking about some of those and the JSON tables a little bit later. And I've just got my the get is a little bit more complicated, as I have to sort of unmunge and unmarshal string to JSON, as I'm effectively getting a JSON string. The data type JSON is stored as text in MariaDB, and you can index it if you want. And then I'm unmarshalling it as JSON and into a dictionary in Python, so I've got something native to use as well. But as far as I'm concerned, for my environment, I'm just putting dictionaries in and values in, and I'm getting values out. So I wanted to talk about this. So why no SQL? People talk about the issues of scale and complexity and setting up systems and easy setup and things. And I don't know many that are actually as easy as MariaDB. But I think a lot of people gloss over the fact that at the end of the day, you've still got developers interacting with your systems, and they're importing drivers and libraries. And I made this abstraction, this toy abstraction. Do not use this in production. Goodness me, do not use this in production. But it just goes to show, I could just do a few things. I could just do there we go. I've set up my table, and in my init script, I've hidden all that complexity away, creating a table, creating a database, and then in my 956 line, I've just got my one thing I want to put. I think ideally this would be an asynchronous push to a different backend, which then handled the complexity again. And this is the kind of thing that I kind of see when People say, why NoSQL? I say, well, because it's simple for people. You're already managing data and collections inside your code base. Doesn't matter if it's Java or Python, Ruby, C Sharp or something. You're still adding complexity to your code base when you add more systems. And NoSQL, that trend definitely took away some of that complexity. But as I'm trying to prove here, you can absolutely hide that. Do it once, do it well. It doesn't matter if you use an ORM or make your own mad abstraction there like this. You can still make life good for you and keep it repeatable. And people might even come up to you and say, hey, ask you in the code base, say, hey, what's this? Where's it going? I say, oh, it's going to a regular database. So how do you do that? Just a little bit of abstraction. And you can still move all your common problems and error handling to a different part of your backend, or a framework or library that you import elsewhere. Let's have a look at this inside the database just to prove it. MariaDB. Show schemas. I've got one called KVDB. Show tables in here. So this is where the name of the collection came in. What I was calling the collection. Game scores. If I just select start from game scores, see, there we go. There's all the rows. You'll notice the IDs are a little bit high currently on the auto increment. In this little library, I also added system versioning, so I could do. The idea was when you do have a single key, import KVDB. Ta-da! Database connection. See, easy peasy. So .get. I could specify a when equals last, and I think I could do for just that bunner key, not buffer. Goodness me. There we go. So that's the last one, or I can do all iterations on that key. There we go. So what is that? What am I looking at? So as I said earlier, the problem with writing a single key to a key value database is you've only got one key to update, and I'm handling that with an update replace in MariaDB, but I'm still maintaining all the history using system versioning. Let's have a quick look at that. In fact, I could show you the code and where that looks. So I just add this little string to the end of my create table statement. Create table, if not exists, the name of the table. So it's kvdb.collection name, game scores, and I've added system versioning. So even though I've been overwriting one key over and over again for that first part of the program and the end, I've still got all the history for it. I can still go get it back. People with I would never use this in like a transaction environment. I mean, why keep overwriting one key the whole time when you could just keep appending? Then you've got the full history as well. But it adds for an interesting notion. You can also show the history of any key to see if there was any issues in your or any row. If there's any issues that were kind of a weird update came along, or perhaps someone's updated something they shouldn't have when they should be using some kind of append methodology rather than updating existing keys. Mark a row as deleted, then add another one afterwards. But that's just semantics of whatever your application or your data model is, or however that's supposed to go together. So why NoSQL? It was convenient at the time, but there's no reason why we can't keep making things convenient for ourselves still. The ingredients I put into this, Python. That's quite an obvious one. What kind of put this all together? MariaDB, of course. It was a total ruse. I didn't make my own database. That'd be ridiculous. I just use a really good one instead. MariaDB connect to Python. A great addition to the connector roundup. I use it often. Love MariaDB, love Python, as you can probably tell. Enjoying it. JSON functions. Recently in 10.6 they were touting JSON tables, which is a different thing. JSON functions have been around since 10.2.3 in various styles and versions. Different things kind of pulled it. There's different things have been added. So go look at the JSON functions page in the documentation. You'll see if you're running like 10.6 now, 10.5, 10.6, most of them are there for you. JSON tables is something new where you can represent and store JSON as a table, which is different to dynamic columns and virtual columns. But yeah, this is just JSON functions. And the beauty of JSON functions is, compared to JSON tables, is I can just start adding it to any existing table. And that's all I've done in this project. Is I've got a table with a key, which is a column called K, which is my key, and that's got an index on it. Then I've got a value, and that's where I just keep my JSON value, and I can marshal, unmarshal it, serialize, deserialize over the wire using the connector in and out of Python dictionaries. Easy peasy. So JSON functions, when you want to add or not just have like a one and done solution. System version tables. This appeared in MariaDB 10.3.4. Great, love this feature. I'd seen it elsewhere before, so I'm really happy we've got temporal data methodologies here now. MariaDB dump recently got updated with the ability to have like a dump as, so you don't have to take the whole table and all the versions. In a logical dump, you can take just a specific timestamp, timeline, or time frame, and that's been very interesting, and a good addition as well. It gives you more flexibility. I still see MariaDB dump, a MySQL dump used in ETL pipelines. Further reading and watching. JSON doesn't just end here, and NoSQL and flexible data types don't end here as well. So as I said, JSON tables came out, and that's a different thing. Sergey did a great talk in FOSDEM earlier this year, JSON support, news, non-news, and the bigger picture, and he dives more into like the functions and functionality around JSON document parse and values, and what the future holds, or things like optimizer, how the optimizer is going to handle things. That's a great talk, very in depth. The max scale NoSQL listener, and there's an example below from my colleague Robert from Developer Relations. This is a talk in its own, and this is providing MongoDB compatibility on the wire via max scale, and it's well worth a watch and a listen and a read. So if you've perhaps already made that terrible mistake, you said why NoSQL, why not, and you chose something with a document DB in it, and you've already got the MongoDB protocol everywhere around your codebase. This is there's also been stories before on our commercial blog about MongoDB migrations. So it is happening, and it does happen. MariaDB isn't the only target for MongoDB migrations, but at least also 10.6 enterprise and things like this. More Oracle support, Sybase ASE, Sybase SQL Anywhere. There was some TDS, MS SQL ASE things in previous versions, compatibility, and now MongoDB wire protocol at the max scale level. This is providing people a lot of flexibility. So hey, if you're still enjoying like the MongoDB libraries, but you want a better database on the back end, not a bad way of doing it. Dynamic columns, as I said as well, I think this deserves another talk. If you want that flexibility in your schema, being able to like add new data types, and you just want to extend the SQL a bit without doing any extra database migrations and handling more DDL and rollbacks, dynamic columns is a great thing to look at. But it's a talk on its own, and it also means that all the data will come back as result sets in Python as row-based result sets, and not it won't be like JSON that comes back. As far as you're concerned, it will just be rows and columns and then flexible types within them, and that's it. So yeah, I hope I answered that question, not just for myself but other people as well. Why NoSQL? Because I think it was a win for developers. And I hope I've proven that it could be just as easy for us as well on the relational database side, and MariaDB is definitely proving that. Scale to the moon, infinite types or no types. Thank you very much, and I hope you're all doing well.
Okay, hi Richard. Very nice talk. Thank you very much for all this presentation and and explaining me a bit more about NoSQL and all these Python connectors. I am more on the operational side than developer, so this is more the scaling stuff that will interest me. But so you spoke in your presentation about the fact that this is not ready for production. What would you suggest? What are your advices for I don't know, creating a challenge, a worldwide challenge on Bunny Bunny game?
Oh, worldwide challenge. I touched on if I could do the talk again, I'd probably focus on distributing data over more tables to avoid collisions and stop overwriting and reduce the load on perhaps where you're building your views, that your models or controllers or data ingest models might be happening somewhere else. It's okay to keep appending to a table as long as you keep data unique. That's an easy kind of scale technique. Just append. Don't worry about inserts or updates. Updates or deletes. You just keep inserting and then push it out somewhere else later. I think this is the kind of the beauty of some of the JSON functions and NoSQL. It's great that we can kind of keep compacting onto a single document object model and keep expanding it and not worrying about the types or the values and the names of the fields and things. We can deal with that later. Whilst we're at least scaling, particularly whilst we're dealing with multiple languages and multiple countries, you can just keep adding data and then do your roll up elsewhere. Because you might have be dealing with different Unicode, different kind of character correlations or encoding, and just need to just worry about it later.
Okay, and about any suggestion about what kind of tuning, about what kind of options we should maybe take care of in a typical MariaDB instance or a cluster setup for this kind of data, of NoSQL data?
I think one of the easiest solutions I've ever had to kind of dealing with helping to kind of like keep this transparent has been MaxScale. A great tool, and of course I mentioned it in the talk as well. They've already offered their NoSQL protocol on top of it, which is MongoDB compatible. So if you already were working on something, you can now go to something which will kind of take the scale a little bit better, and start offering you different data model options as well. Options is really important on data. If you're kind of stuck with one model and it will only go like this, and you've got no scaling options, then that's kind of it. We also host MaxScale inside SkySQL, and whether you've got MaxScale on site or with us or both, you can start mixing these things around. At the end of the day, they're just protocol servers all running and understanding the MySQL MariaDB protocol. So it's easy to write somewhere, put it somewhere else, and manage multiple data types. Options are good.
Okay, and I just take a quick look at the blog post about MaxScale Listener. So it's ready for production now. So it's already working and ingesting NoSQL.
Yeah,
right?
I'm keen to see or hear more people using it in production. Likewise, I'm just kind of playing with it at the moment. But I'm really keen to get on a project using that.
Okay.
I think within my local user groups, we're going to play with. I'll probably start doing something like, let's take a Mongo application, let's stick it on MaxScale, and let's see how far we can push it. Let's start gaining those options over the types and scale. And it's just those extra things like, well, I could put some data over here, and I could put some data over here, and I could flush caches over here, and then build up my model elsewhere without impacting any other services. We've got that option where we've got so many different replication types in the MariaDB world now. We've still got our normal asynchronous replication, synchronous replication, WAN synchronous replication with Galera, expand, of course. I could dump data into column store and then archive off to S3 natively, all without leaving MariaDB. So I've got a lot of options, and I can now I've got ways to kind of hide that from me, and also the protocol to the client and developer level with options with MaxScale, but also then I could just go to something like SkySQL if I need to move a particular service off-site or into a different region.
Sorry. Yeah. Okay. Sorry, my screen went black suddenly. Okay. So well, that's really interesting. I think I have no more questions. Maybe you want to develop about a specific aspect about your presentation, something that you missed, or something that you wanted to say.
Yeah, I definitely wish I'd touched more on the single table for storing key values. So you talked about how do we scale these kind of services. So I've got options for like within the MariaDB world, as I said, for like even WAN scaling with Galera and Expand and this kind of thing, and then kind of hiding those with max scale. I can also just start firing up different regions in SkySQL. If I'm perhaps operating from the UK, I could just put a data center out in SkySQL in East America or anywhere, and then just start sending data there, or picking up clients there, and then having another location where I put things. But I wish I touched more on the if I was to do the talk again, I'd spend more time on the table model, like I said earlier, like the append thing, and then how I do a roll up, or cherry pick the data that I feel is necessary, or open up the that would be my opportunity to start trying to enrich or do something else with the data, or even just like merging data from elsewhere. I think that's something that I would like to have touched on more.
Okay.
But I feel like half an hour probably wasn't going to be enough for it.
Yeah, it was pretty short. Maybe for another test we could speak about this more deeply. Well, thank you very much.
Thank you, Faustin.
Bye-bye.
Take care. Bye.
Good morning, good evening, and good afternoon. Thanks a lot for joining my session for this MariaDB Fest, and hopefully it's going to be like an interesting half an hour. We're going to talk about an interesting topic that I've been researching lately. It's called supply chain attacks. And I hope you will find it interesting and pretty resourceful. My name is Dan Dimitar. I'm part of Kaspersky's Global Research and Analysis team, in short, GREAT. We focus on attacks which are, let's call it advanced, and you might have heard about like APTs, Advanced Persistent Threats. Me and myself, my colleagues, we are almost like 40 plus experts in 20 different countries, and we're mostly doing threat intelligence and research. As I mentioned before, we are focusing on advanced persistent threats, on attacks against banks, governments, banking institutions, of course, and financial threats as well. And we also monitor the current threat landscape, and whenever there's like a large-scale attack, we are there to identify, to research, reverse, and publish our results. You might have heard of some of our research. We started in our more than 10 years existence. We published a lot of research, and some of them you might have heard about, like for example Stuxnet or DQ or Flame. My favorite would be like Equation and Satellite Torla. And this is all the research we've done in the past, let's say 2000 and 2016. And you might ask, hey Dan, why isn't research from 2020 here or from 2019? Well, it's because it won't fit in a screen. We are monitoring and we are like checking more than 900 operations and groups, and this was only in the last year. 20 of them are commercial ones. So what do I mean? What do I mean by commercial? Basically, there are groups which are financially motivated. They just want to get money. They're not like interested, especially in cyber espionage, in like stealing data. No, they just want to get money. And the question is like, how do they get some money? How do they steal money? Well, they deploy ransomware attacks, which are like huge, quite popular these days. They do extortion. They do like a sphere phishing, and all this kind of stuff. Also, we monitor from those 900 operations and groups, we noticed that 25 of them are Chinese speaking, which is a lot. And this trend, unfortunately, it seems that it starts to increase with more groups from same regions or same geographic areas. They compete with each other, trying to steal and trying to infect and get access to networks. So I would like to show you just a glimpse of the research and the things that we are doing. And basically the idea is that we cannot research or we cannot do everything by ourselves. And 80% of the malware that we see currently in the wild, fresh malware we might say, is actually crimeware. It's like petty thefts, small crimes, keyloggers, maybe some Trojans, some remote administration tools. You know, people just trying to steal some credentials or to steal some of your money, or like banking Trojans, etc. Those are automatically detected and not so interesting. Then we have targeted attacks, which are 19.9%. Those targeted attacks are more advanced. They require more prepping time, and attackers actually they do their homework when they try to infiltrate your network. They research a bit about their victims, and then only when they have the information they launch the attack. And then lastly we have 0.01% of the attacks which are advanced persistent threats, and those are the ones which are juicy, I might say, or interesting for my group. And those attacks are the ones that are extremely dangerous and with a big impact. You might have heard about huge ones. So for example, SolarWinds, which we will be focusing on a little bit later. These kind of attacks are really advanced, and we analyze them. It takes us from weeks to months to actually fully understand the attack and write a report from it. But of course, we cannot do everything by ourselves, so we have a lot of robots, we have a lot of data, and with this occasion, I would like to thank from our hearts, thank you all the developers, all the people from MariaDB Foundation, mostly because we run Linux on our systems, and we are using for our relational databases, we are using MariaDB, which is a super cool software, and we like it a lot. It's really stable, and it helps us in our day-to-day life in order to do research. So thank you very much, and thank you for giving me this opportunity to come and meet and greet you, and hopefully we'll do some more collaboration in the future. Now, of course, before we talk about supply chain attacks, I would like to give you a short introduction of the current threat landscape, what's out there, what's happening, and just to put you up to speed of what's been happening in the last year. We're almost in Q4, and we've seen, based on our telemetry, based on our knowledge, we've seen that more and more network appliances are being targeted by the attackers. So in the past, it used to be only Windows platforms, maybe a little bit shy of macOS platforms, and not so much on Linux malware we've seen. But nowadays, more and more devices are being attacked, especially routers, which are home routers or small office software routers. We've seen VPN networks, VPN appliances being targeted. Last week or 2 weeks ago, there was a huge dump of more than 500,000 Fortinet devices which were hacked, and 500,000 Fortinet accounts which were leaked. I found a lot of, let's say, governmental institutions in the leak as well, and attackers were exploiting a 0-day in the Fortinet in order to dump the users and the passwords. And let's think about it. It's pretty obvious or pretty clear that attackers especially in these times of remote working and more people are like working from home instead of in the office. VPN gateways are a safe passageway through the corporate network. If you manage to own the gateway, then you are able to actually get into the network. If you manage to compromise access from one user, maybe you do like some spear phishing, maybe you do some social engineering, and then you meet somebody from the victim company, you meet that person at the bar, and then you manage to that person, basically the attacker steals the laptop and then manages to access the credentials. Basically, VPN is a way into the company's network. Also, social engineering and phishing attacks are also pretty popular these days. Now, when we talk about like APT attackers, we've seen that instead of like wasting a lot of time and a lot of resources into trying to break into a network to the victim network, APT actors are actually buying initial access from cyber criminals on dark markets mostly. And this is like a win-win situation for them, mostly because they don't have to wait a lot of time to find a vulnerability because somebody else already found it and they're just selling it. And of course, APT actors, they have like some resources, either from stealing it, like if it's like, for example, Dark Hotel, which is like a Korean-speaking APT, they steal a lot of cryptocurrencies, so they have money to buy access to in order to steal more money. Ransomware, which is huge these days, I would say it's the like #1 threat right now. We have like ransomware groups and underground markets being developed, and more victims are being targeted by ransomware groups, and basically they do extortion. They just get access to your network, they encrypt all your files, and then they say, hey, would you like to get your files back? If yes, pay us $5 million. And this is what happened with the Colonial pipeline. This is what happened with let's say Garmin, and many more, like FIFA, for example. As well. We have like EA games. We have like a lot of examples of companies being targeted by ransomware gangs. And APT actors, of course, they will follow the trend, they will try to use the same techniques, and of course, they will try to leverage whatever access possible in order to achieve their goals. Basically, we have like a bigger attack surface with more devices being connected to the internet, with more destructive attacks in the future, attacks which can and possibly are able to disrupt an entire city or maybe an entire country or like a portion of like a country, and deliberate attacks or collateral damage. Now, this is an interesting topic because maybe you might not be the like sole purpose of like the target of the attackers, but if you are part of their attack plan, then you might be collateral damage. And I wanted to point out this last step, collateral damage, because this is an introduction into the supply chain attacks. But before we talk about supply chain attacks, let's actually talk about supply chain. What's supply chain? And researchers from ENISA, basically they published a paper which was published in July this year. It's called Threat Landscape for Supply Chain Attacks from ENISA. It's amazing. I would suggest you go check it out. I've put a link here in the QR code. In their 50+ pages paper, they define and they talk about supply chain attacks, what happened in the past, what are the thoughts about the future. And I just want to mention some of the key facts that they mentioned there. And in order to talk about attacks, we actually need to talk about like what's supply chain. And I think they have like a pretty good definition. It means like the ecosystem of processes, people, organizations, and distributors involved in the creation and delivery of a final solution or product. Well, that's pretty cool. And we have four main things. We have a supplier which provides some goods. It can be like digital, it can be like real life physical goods. The supplier creates something, and then the supplier has some assets. Those assets are being used by the supplier, and then they can be moved around. And then we have like clients which are using or like consuming some of the assets that the suppliers are producing. And lastly, we have client assets, which again can be like digital or physical. Let's say a client has like computers, buildings, offices, this kind of assets, but also a client can have like a laptop, servers, and so on. So your life kind of, if I'm not mistaken, depends on a supply chain. And we are part of at least one supply chain. Either it can be like food, or it can be like products or goods. So without supply chains, our world would not function today. So what's a supply chain attack? Well, it's simple. The idea is that an attacker knows that their victim relies on multiple suppliers. The attacker also noticed, or maybe did some reconnaissance, and saw that like the victim, it's not so easy to hack. Maybe it has like good defenses, maybe it has like a lot of monitoring. So what does the attacker do? Instead of going for the victim directly, it goes for one of its suppliers. So the first attack is on a supplier that is then used to attack the target. The target can be a final customer or another supplier. It can be like in a chain, supplier of a supplier of a supplier, and then over for a victim. So therefore, for an attack to be classified as a supply chain one, both the supplier and the customer, they have to be targets. The supplier will be a target in order for the attacker to infiltrate or to inject its malware, because we're talking about cybersecurity, to inject the malware into the product that is going to be used by the victim. And this is pretty interesting, because if you think and if you make like a small napkin calculation, you will see that actually for sure your organization uses at least one supplier. It can be like software development, maybe you're using like an editor, a text editor, maybe you're using like a specific Linux distribution, maybe you're using a specific cloud provider. For sure you are using at least one supplier. And then let me show you an example, again taken from the threat landscape and supply chain attack report with CodeCov. Basically in 2017, 2018, CodeCov was hacked. But the attackers didn't focus on the CodeCov company itself. No, they were going for another customer. But they knew that the customer was using CodeCov. So what did the attacker do? They managed to find a bug with the instances that CodeCov was running. They managed to get access to the instance. And then from that instance, they managed to inject a malicious bash script. So at this stage, CodeCov network was compromised. The attackers managed to inject their own script into the bash basically to inject their own shell code into the bash interpreter, which was bundled into the images. And then when the customer downloaded the infected malicious image, the customer didn't know, because the customer trusted it, because it downloaded the image from a trusted source, from CodeCov. So when the customer spun up the image, like built the image, the attackers, through the modified bash script, they managed to get access to the client credentials, and then from there, with those credentials, they managed to access the private Git server, getting access to the source code of the client. So this is how the customer got attacked. This is just an example. There are numerous examples of, and we will be discussing some of them a little bit later. Now, you might say, Dan, what's the history of attacks, and we see that the earliest attack is from 2003, the earliest known attack or documented, because we don't know exactly, undocumented one, maybe nobody knows about them. We have like some Gentoo and Fedora servers which were illegally accessed, and then attackers deployed some malware on them. Now I'd like to give you some examples of later examples from the 2000 years, 2010. We have this RSA, and I'm using one, maybe you're using one as well, those RSA tokens. And in 2011, there was like a huge news saying that the security from RSA offered to replace those tokens because it got hacked. And then the big question was, is RSA the final victim, or actually attackers are going after somebody else? And then how did the hack happen? It was on 0 day, attached in an XML file, XLS file, sorry. And basically in Excel, somebody got the email, and then the employee executed the spreadsheet, and then from there the attackers managed to infiltrate the network. So this is not like unheard, and it's like it is what it is. But then the RSA chairman, executive chairman, said that information taken from RSA in March had been used as an element of attempted broader attack on Lockheed Martin. Initially, Lockheed Martin did not confirm that they were also a target, saying they were in breach. But our RSA executive chairman said that the hack on its company actually tried to impact its customers. And of course, you might know that Lockheed is one of the world's largest suppliers of weapon systems, fighter jets and warships. So this was pretty interesting back then. And then we have another hack, like 2 years later. And then Bit9, which was actually, which acquired Carbon Black, which then was acquired by VMware in 2018. And now it's kind of called Carbon Black. But in the past days, if you are familiar, if you work in cybersecurity, you've heard for sure about Bit9. It's like a whitelisting solution in order to make sure that no binaries except the ones which are whitelisted are executed on a Windows platform. And basically they got hacked. And they said that, only 3 customers were affected by illegitimately signed malware because the attackers managed to get access to the signing servers. So this was interesting because the company said that its clients are like US military intelligence agencies, 5 of the top 10 aerospace and defense companies in the Fortune 500. So this was pretty big because, again, same as RSA, the attackers were not going directly after like Bit9, but they were actually going for the clients. Okay, let's go a little bit later. We are in 2017, and then you might have heard about the ShadowPad APT. So my colleagues in Kaspersky, they found a high, high-end APT implant hidden in a management software during initial response. Basically, we have this NetSarang company which was providing a software, and they got hacked, and their products were being replaced and signed with a valid certificate, but the products themselves were distributing malware. So we did some research, we analyzed it, and then there was this another hack, like almost around the same time, where CCleaner got also compromised, and users were downloading malicious, compromised updates of CCleaner from the official website. And everybody was asking, so, oh my god, who is behind these attacks, and then what's happening? Well, 1 year later, at Virus Bulletin, John Lambert from Microsoft Research, they proved, and they mentioned that the Barium APT was behind ShadowPad and NetSarang and CCleaner attacks which were earlier documented. So this is pretty interesting. We have like the missing link. We have an APT group which were targeting all this kind of software in order to get access to the client. So basically a supply chain attacks. And then we have like this huge story of 2019. Maybe you were or maybe you weren't impacted. Basically, we found users started writing messages of an interesting update for ASUS critical ASUS updater. And first of all, the binary itself had a typo. It was like the name was weird, but also it was not detected as malware at all. So people will say that it was legitimate, but it was kind of shady, you know. And then we have like this the name. The spelling of force and the empty details are like kind of odd because ASUS, a legitimate software company, like and hardware, they have their software bundled okay, but you know, like nobody knew exactly what was happening. The file was clean, but we can see exactly that like there's a typo in force instead of force, and you know, everybody was like, hey, you know, like probably because ASUS is a German company, so they have this typo, so you know, like maybe the file is clean. And then we were like, okay, sure. And then one of my colleagues interestingly found that in January 2019 we found some more updates, and then in those updates we found that there was a file, a zip file, hosted at a legitimate ASUS download server, but the file itself, having a valid signature from ASUS Tech, actually it contained malware. So this was pretty big, this was pretty huge, because my colleagues, identified that we are actually confronting with, they were investigating a supply chain attack, and ASUS was the victim. So the binary itself was pretty interesting, but I don't have time in order to go like in-depth details about it. Maybe at a later time I can point you to our research, our published paper, which has like all the details available. But the binary itself, it was saved, it was marked as creation date 2015. So that was like pretty interesting. And one aspect I would like to tell you about this malware, which was distributed from the ASUS update servers, like legitimate update servers, is that it wasn't targeting all the users. No, it was targeting only with surgical precision 400 MAC addresses. So basically, the malware once the update was downloaded from ASUS, and then the malware was executed, and then it was checking for the MAC address of the system. And then the attackers actually had a list of 400 MAC addresses, like a bundle in the malware. And only if they detected that specific MAC address, the malware was getting the second stage, like logo.jpg, and then it was executing the second stage payload and infecting the computer with more binaries. Out of those 400 MAC addresses, we've seen more than 270 are from ASUS Tech, but it's interesting to see that we also have some Huawei devices. One MAC address belongs to a Huawei device, and also TP-Link and Realtek. So the attackers kind of knew what their victims were, and we don't know exactly who those victims are. So if you have information about those MAC addresses, you're welcome to ping us. So the story doesn't end here. Again, if we look at the NSA report, we see that in 2021 only, and it's this year didn't finish yet, we have a lot of attacks. And you might have heard about the huge, now so well-known attack about on SolarWinds with their Orion software, but you might have heard about also Kaseya or the Apple Xcode, which is an interesting let's say attack, and we will be discussing it a little bit later. Also, I was directly impacted by one of the supply chain attacks on CETA website. Basically, airlines are using CETA website in order to handle passenger information, and because CETA was attacked, I also got impacted by this attack because of the Singaporean airlines, which were cooperating with SITA. Well, what I wanted to show you is that once a supply chain attack happens, and if you run and if you execute the binary on your computer, then you you will get infected with malware which is pretty complex. So if we look back at the shadowpad attack that I mentioned earlier, we see that it's actually just a reconnaissance tool with a backdoor, allowing the attackers to actually snoop on your device, see if the device is interesting enough in order to further backdoor it and further exfiltrate information from it. The malware itself is able to detect Windows versions from 95 to Windows 10, which was like huge at that time. And of course, it has an option to download the files, to run files, and to uninstall itself once the attackers are finished like identifying your computer. So the malware itself is pretty complex. But we also have some cases where supply chain attacks are actually not proven to be like false or proven not to be like what they are presented to be. And you might have heard about the huge story in actually almost 3 years ago in October 2018 with the Supermicro servers, which had like a tiny chip implanted by they say Chinese spies, but actually researchers and people tried to look into it. Joe Fitzpatrick, he actually said that I want to see the schematics, I have the tools to analyze it, and it turns out that the pictures we were given were actually template rendering, so the pictures we were given were not useful. The sources in the article were actually not mentioned, were anonymous sources, and the entire story, there's a 80% or 90% chance to be like fake news. It wasn't substantiated. There's no like real basis of the news. So basically, it was a waste of time, but it was cool because it was a supply chain on hardware. Of course, not all the supply chain stories are fake. And the main reason we've seen supply chains being mounted in currently is because we have like pretty good defenses. We have like antivirus, we have like firewalls, we have like EDR, XDR, we have like whitelisting, etc., etc., etc. So basically, the attackers, they need to find new ways in order to actually infiltrate or penetrate the networks of their victims. And high-end actors will always have a way to reach the target, but medium and low tier actors, actually, they will try to either move along or they will have to find new options. And supply chain attacks are interesting because you don't have to go for the attacker itself. You have for the victim itself. You can actually go for the supplier. Maybe the supplier has not so good security, or it's like it doesn't have like a really good security team. And why is it hard to discover supply chain attacks? Well, because they abuse the existing trust. The attackers, once infiltrating the network, they can hide in the shadows. They can inject their malware into code which will be then signed with certificates, the software will be trusted in the chain further up. And then there's like this huge confusion because, for example, in the WannaCry, people were saying like install the patches, and then like for the MIDOC, which was like Ukrainian supply chain attack, which happened in 2017, 2018. MIDOC softwares were compromised and they were distributing NotPetya ransomware, and people were saying do not install the patch because you're gonna get infected. So it's gonna be like crazy. That's true. But what if you manage to inject a backdoor and the code is clean? Well, the code will get like digitally signed automatically. The injection looks like maybe the developer tried to create it on purpose, but the source code review doesn't show anything because the injection is like at higher level in the CI/CD build. So it's very important to make sure that if you are a company which creates or distributes software, not only your developers have to be like secure, and they have to have like really good security practices in order not to introduce bugs in the software, but actually the entire build chain, your entire build chain needs to also be protected. And of course, the attackers, they know who are their victims, and they also only plant. There are cases where they only plant malware into select projects. They will not expose their code only to the entire world. And because you are developing like a really good product at MariaDB, and you have like a lot of developers, we have like a lot of enthusiasts, a lot of users of software, of like MariaDB servers. I want to point out a supply chain attack that happened this year, and it's not new. Xcode, there were multiple instances of Xcode editor being injected with malware and being distributed. For example, in Southeast Asia, where there are like the internet connection is slower, and then people prefer to download Xcode from like servers closer to that region. And then we've seen cases where there are like Trojanized versions of Xcodes were distributed, were released, and then like users, unbeknown users, they were like downloading this Trojanized version of Xcode, which was then compiling all the projects installing malware in them. But this attack, which was discovered by the Sentinel-1 this year, was actually different, because they documented a way where the attackers were promoting a malicious repository. And the malicious repository was top bar interaction, which was legitimate. From GitHub, a legitimate user created this project. The attackers cloned this project, and basically what they did, they added a few instructions in the build process for Xcode, such that if you downloaded this malicious repository from like Git repository, if you tried to build it, then your Xcode would actually execute commands, and your computer would get infected, allowing the attackers to get access to your computer. It was actually creating a reverse shell to their C2 server. So just by downloading the software and clicking the build button, which generates like a huge artifact, the attackers would actually be able to own your computer. And this is not new. Like Google disclosed in January that North Korean Lazarus hacking group was also conducting social engineering attacks against security researchers, trying to make them run malicious code on their computers. So this is not new. And then you might say, Dan, what are the solutions? And I would say there are different types. There are different things you can do. If you're a user, if you're just using the software, you will have a trust chain. But when you have the trust chain established, try to follow the trust chain. Try to check the fingerprints of signatures. So, for example, on MariaDB, they provide packages where you can download the latest updates, latest MariaDB server packages. You can go to their website. You can install the repository on your server, and you can fetch the updates directly from them. But then, once you download anything from their website, also make sure that you verify the signature. Also make sure that you import their signing key, and everything you download, you check to make sure that it's signed by them. Maybe you have like a man-in-the-middle attack in your network, and then the attackers redirected your download, and it's not coming from MariaDB official servers, but it's coming from a server controlled by the attacker. Check the signature. And also you can limit the supply chain length. You can limit the number of vendors that you're using in your company, and also make sure that the vendors that you're using are actually, let's say, security conscious, are doing like security, they have like a bug bounty program, they have like a security team, and they react fast to security events which are happening in like reported by users. So this is how the information from MariaDB looks like. You have like all the information about like how to get access to the bug bounty program, like where to get like the signing keys, their like email account in order to tell them about like security bugs or to report bugs. And what about like what if you're a developer? Well, it's very important to make sure that the signing keys are secure. Once you release a software signed by you, then the entire world trusts that the software is clean. And this trust is like so easy to break if you if your signing servers are compromised. So you have to make sure that the signing keys and the signing servers are secure. You have to make sure that your build chain is also secure, because even though the code on GitHub is like properly validated with pull requests and approvals and everything, if somebody goes in between the code and in the build chain between when the code is fetched and the package is built and inserts the malware, it's very hard to see. And also, developer machines are very important because they also have access to private Git repositories. They have access to the source code. Of course, for MariaDB, it's a little bit easier because it's open source, so all the code is like out there available. But developer machines are important because they give access to further resources into the organization. And of course, bug bounty programs are really important in order for white hackers to be motivated to report bugs. And I've seen that a recent article which was published on MariaDB Foundation, Challenges and Visions for MariaDB Server, and I fully agree with the article, and I think it's really important that you as a software company developing like really good software, you have to have a way in order to have your builds to be verified and everybody to be able to build their own from the source code, build their own tools, or to be able to reproduce the builds in order to identify any differences if there's like some malicious code on the binary which is hosted on the update servers, on your update servers, and the software, the build that they created on their computer. So it's really important to have like this mindset and this forward going into the future of like always updating your continuous integration and the delivery in order to make sure that you have like really good software. And with this being said, thanks a lot for coming to my presentation. I hope it wasn't too long, and I'm here to answer any of your questions. So thanks a lot.
Hi Dan, thank you for your talk. Very interesting. I am Faustin. I am in charge of the infrastructure at MariaDB Foundation. We don't have a very big infrastructure, but we have a quite big and growing building infrastructure for all the packages that we are providing, all the binaries. This is made about cloud vendors and very heterogeneous machines because we are building multi-arch binaries. So the question about the security of the building chain is really important to us. As you mentioned, user as the solution of verifying that every binaries that we provide them are signed by our keys. And there is another option that you maybe not mentioned, is about the possibility to rely on the distribution and on the package management from the distribution. On what do you suggest? What is your opinion on using the upstream binaries or relying on the distribution? What's your take on that?
So thanks a lot for giving me the opportunity to present at your conference, and this is a really good question. Yes, I think it has multiple options. Like from a user standpoint, it has multiple. You have multiple options. Myself, I'm a Linux user. I'm a Debian user, and of course, it's easier to just like go into terminal, like apt install MariaDB -server. But that package comes from the official Debian repository. In my opinion, I think, and from what I've read, you also provide some Debian repositories which are more up to date and with the latest code. Yep. So now the challenge is, will the user want to manually add an extra apt source, apt repository to fetch the latest Debian package for MariaDB from your official website, or will the user not want to do that and just download it from the Debian repository or whatever other Linux distribution or Windows they're using? Windows is a special case because there are no like repositories. Let's talk about Linux here. And from my point of view, I think there's like, the question is, where do you put your trust in? Do you trust directly MariaDB? And then in this case, you should put your repositories to download them directly from the MariaDB repository? Or do you trust the Linux maintainer, which it might be or might not be affiliated to MariaDB? And from what I've seen, there are multiple different maintainers for Fedora, for Arch, for Monaco, for Ubuntu, for Debian. Basically, those users, I don't think, and maybe you can correct me here if I'm wrong, I don't think they're directly or officially affiliated to MariaDB, but rather they just they maintain the source code and they just publish new updates. Also, they might be late, or they might be behind official updates versus compared to the website.
Yeah, well, so this is indeed true. Well, it depends on all the distribution. I don't know very well how it works for Fedora, for instance. I know the particular case of Debian quite good. The thing with Debian and Ubuntu, because we provide packages for Debian. In the case of Debian, this is the same person that maintains for Ubuntu. Yeah, this is I think a good question. Either you want to rely more on Debian and you trust Debian because, well, it's kind of historically a trustful, in my opinion, distribution. Either you prefer to rely on MariaDB. And there is another aspect that you mentioned that I think is quite interesting and important to take in consideration is if you maybe are more interested in having the updates as soon as they are provided and the patches. I think in the case of Debian, when there is a very problematic and really impactful security patch, then it goes much faster than just for a new feature or something like that. But yes,
I think I've seen this case, whereas from the upstream, from MariaDB upstream, an update would come faster than the one from the official Debian repository. I have another example with, well, you know, like I'm using all kinds of browsers. I'm also using Google Chrome. It's exactly the same. Like Chrome from Debian is a little bit behind with versus repository maintained by Google. And when there was a 0-day in Chrome, and I was like, oh, okay, I have to update. I need to update my browser because like the patch didn't arrive 1 day later than the one from official Google repository, which they released it immediately. When they released the blog, they also released the update.
So this is... Yeah, of course. So yeah, this is a very important aspect to take in consideration. You're true. I had another question because we are speaking about relying on the distribution package management system or on MariaDB. what about building your own binaries? This is something we are trying to make every time more easy. We are working, for instance, these days a lot on providing Docker's containers, so the user are able to test them more easily. The building of MariaDB is quite long because it's a big piece of program, but this is not difficult to do it. Do you know users, or I would say maybe paranoiac users, or but if you are working in the financial ecosystem, I guess some users will rely only on the binaries that they are building.
Well, yeah. First of all, it depends on how well set up your infrastructure is. If you have like OPSEC person who just knows how to has like an entire build chain and downloads the source code, builds it, like pushes the updates to their server, then it's quite easy. Personally, I did that. I did download the source code and compile it myself. I have a really good friend who says that code never lies. And the first thing, and is the most important thing when you try to go on this path, is that you need to download from the official source. So I think in your case, it's GitHub. I would add also that you should check, or maybe MariaDB should enforce, and I'm sure if that happens, that all the commits are signed, cryptographically signed with the public key of the developers. So this is what we do in our organization. Everything that is pushed needs to be signed. If it's not signed, then basically the Git server rejects the commit, rejects the push. And once you verified that all the commits are signed, you verified you're downloading the code from a trusted source, then you kind of established a root of trust, and then that code is trusted, hopefully, and then you can compile it yourself on your machine. Now the question is the next question is your build machine secure? Hopefully that machine should be like disconnected from the internet. And then once you build it, and then you get like a binary, you get the executable, you transfer it to the production machines, and then you have like the checksum checked. And then like when there's an update, you go again, download the code, put it on your build machine, and do that. So it's a little bit harder than doing apt update, and then you just get the newest update of MariaDB. But depends on how much time, how much money, and how skilled your team is.
Yeah. So this is of course a bit more difficult, but yeah, for some actors maybe this is something they should do. It's a very good point. Yeah, it's a very good point about the signing about our commits. This is a question I cannot answer at the moment, but I will raise this to my colleagues. This is maybe something we could improve in the future. Well,
you're monitoring the entire commits, and like you will notice that if something is wrong, like immediately you can revert.
This is of course done. But when we are speaking about signing the commits, this is maybe not already the case. This is the only thing.
It's an extra layer. It's an extra layer. Yeah. You know, in security, it's always about adding an extra layers. You don't rely only on your castle walls, castle defense. And then what happens if you get breached? Then it's like game over. No, you have like your initial defense, and then you have like an extra defense, and have like guards, and then you have like an extra monitoring system, and then you have like some hidden monitoring system. You know, it's just like security is like in layers.
Yeah. Well, thank you. I think we are 30 seconds past from our 10 minutes, but was very interesting. Thank you very much, Dan.
Okay. Thank you. Thanks a lot.
let's talk about the semisync. It was introduced as a solution for scalability and better recoverability for MySQL replication around 2008 by Google engineers. Solution was not really based on some academic research, and rather it was ad hoc attempt to provide some of the good features, and while succeeding in making that, so it is really fast compared with synchronous replication that we now have around, and it scales quite well, but a recovery part remains an issue, or rather remained, as we show in this presentation. So the issue that we are discussing today, it deals with recovery, with improved recovery, that myself and Sujata Sivakumar entertained. So we call that work a journey from semisync to three-quarter thing. Hopefully, through the presentation, the listeners will appreciate that increase, and let us see how it will do in practice as well. But first, to indicate what is the issue we are dealing with, let us look at the regular commit protocol. So on this following slide, the magenta user agent submits commit transaction to now a single server is in this blue color box. So it has a few agents, coordinator of two-phase commit protocol, master, the whole box I call, and it also has engine where a transaction gets prepared. We also have another engine, binlog. It's a sort of a resource for two-phase commit protocol, at least in my projection, in my description here. So it also sort of prepares to receive write events, write semantics events of the transaction into binlog. After that, the third phase of the transaction commit runs to commit it finally. It becomes committed officially in the engine. That protocol helps to recover in the following. So say master crashed somewhere between, say, phases 2 and 3. So transaction would be sitting in binlog, and it is prepared state in InnoDB. In that case, logic of recovery is very straightforward for any transaction of this type. So I depict them in light green color. If it has a representation in binlog, then the rule is to commit. Otherwise, transaction gets rolled back. Now let us complicate and come closer to the semisync specifics. So the user still submitting that transaction. And it, now you see two agents in blue color. They belong to one server. And there is also slave, now resource that is distributed out, and maybe number of slaves actually. I just depict only one here. And the same two-phase commit protocol executes, prepare on master, then prepare and commit on slave. Phase, logical phase, logical clock 2 in green encircled. Encircled means green. And when slave receives it, it acts back to the master server, and coordinator captures that acknowledgement to finally execute commit on master. In case of a crash, we should first notice that the most critical part of the crash is here by analysis performed by a number of users of semisync replication. I also recommend to check this nice blog by Jean-François Gagny that describes the problem as well. So crash when transaction does not reach the slave still prepared on master. And remember that when it is prepared on master, I also assume that it is bin logged on master. So crash happens at this time when it is extracted sort of from bin log and never reaches slave. So in this case, we arrive at the following, that master would have G100, G stands for GTID, and small case G here indicates it is not committed. 100 stands for sort of sequence number of that GTID, so it is prepared. And at recovery, by recovery rules presented above, it gets committed. It gets changes from that green color of doubt into blue color of committed state. But at the same time, if slave, previously gray colored slave, becomes a master at failover, so becomes M with superscript 1, it would never have this 100th of GTID. So we have at failover from M0 to M1, formally S, transaction gets lost, and which is not good. And so how are we gonna do about it? First, let us look into the bin log pipe. So bin log represented as a pipe. We have, now I use another the notation here to depict in G uppercase to speak it of it as committed. In smaller case, still preserving that green color, prepared transaction. I and K stands for sequence number, so subscripts is just sequence number. So bin log normally contains transactions in the following at any time at server execution as the following structure. A range of committed transactions, and then a range of transactions in case of just single engine. A range would be not containing any committed ones. So if we have this G with superscript star denoting the last committed, so ending the committed range in bin log. So after that, in case of single engine, we don't have any committed ones. So they will be all in small case. All the G100, 101 and so on would be small case. In case of single engine. Situation gets complicated when transaction on the master consists of multiple branches, a branch per engine. In this case, fully committed transaction would be when each of the branches committed it. So like here, say 1 stands for InnoDB, 2 superscript 2 stands for RocksDB, maybe we have some other transactional storage engines also installed, and then up to from 1 to L we will have all the branches committed. Then we can see the transaction as multi-engine transaction also as committed. Here I represent with superscript I, engine I, and what is important that at recovery, so if we repeat the previous slide, then at recovery the transactions in doubt would actually not be all in small cases, but could be like presented as vectors with indexes of different keys. So some of the engines may have committed, and I'm speaking about recovery, and some may have not. So this sort of structure at bin log we would have after the maximum that on the previous slide G99 is the maximum. So in it all the branches committed. But the following could be like this mix of committed and not committed branches. And those by recovery protocol that we designed and implemented, we must treat this situation as transaction to be committed. So its doubt should be resolved to committed. But task to, and then if that transaction is to be committed, it will also affect computation of that max committed range. And that basically represents a task that we dealt with. And if you need any details of how it was technically done, I must refer you to that 21117 MDEF that myself and Sujata Sivakumar implemented. That's a joint effort work. What recovery works now to respect semisync logics and including multiple branches in transaction. We, after computing the max committed, say it in single engine case, in simple case, would be like this, the picture. So all grain transactions would be cut off. You see them cut off. And Binlock would officially end at G99. So we arrived basically at solution that we implemented. And if the old primary indeed occurred in circumstances that I described, so it can be only reintroduced as a semisync slave. The server post-crash recovery of the server configured with semi-sync slave enabled on ensures through that MDEF 21117 that the server will not have any extra transactions, that old master will never have them. And configured as semisync replica servers, binlog gets truncated to discard transactions proven not to be committed in any of the branches if they are multi-engine, those transactions. For me, it remains to refer you to some of the interesting documents I really like the listeners to check unless it's done. So great source of understanding of two-phase commit protocol and its deficiencies, its various workarounds. This is a book by Bernstein, Hazilakos and Goodman, Concurrency Control, Recovering Database Systems. So our work, of course, though it's not really that well structured as academic work referred above, please check updated documentation about semisync, and I already presented you a nice compilation of semisync features and deficiencies by Jean-Francois Gagny. We're looking forward to improve this part, recovery part, to capture less strict durability guarantees options for the engines. That is roll-forward recovery that was presented earlier in springtime. This type of event, we're still working on it, and this recovery should also understand that engine could be configured not to write any prepared image after each prepare request. So we could relax that and still recover for semisync as well. So thanks for your listening, and this work also requires thanking MariaDB engineering team and personally Sergei Golubchik for a very substantial review.
Andrei, nice chatting to you. Thank you for presenting at MariaDB Fest 2021. I think you had a very, very good presentation, and I thank you for this. Because this Q&A session will be pre-recorded, I'll try to put myself in the shoes of the audience and try to understand the presentation for myself as good as I can. And maybe this way I catch as many potential questions as possible from the audience, because we currently don't have any questions from the audience. So because of this, I prepared kind of a list of questions that I had when I watched your video, and I'll try to get some good answers from you. But thank you for presenting, and I would like now to move to the questions, if you don't mind.
Yeah, sure.
So basically, I think the presentation was quite technical. And it is possible, very probably actually, that some users are not that familiar with replication internals. And I would like to hear from you maybe a summary or something like that on how will this semisync replication work that you've done with Sujata will help the MariaDB users.
Well, I tried to speak some words about the problem that we addressed, and the people already found this workaround using heuristic recovery, which we never designed for this purpose. Yet there were unhappy people anyway, and that solution that they devised was of course limited. It had to remove binary logs from that server that is recovering. So this is the feature that we introduced, this recovery feature. It leaves intact the binary logs of the crashed master, and it's close to be called a universal solution, but it should not, as the users may analyze and understand that the master still has to be introduced as a slave. So that's a limitation we are bound to. But other than that, it's quite a it should ease life of the semisync users, and more than that, it also advances or shows further sort of this spreads our horizon, I would say. Yeah. So we know what to do next. Yeah.
That's nice. Also, you kind of served me the next question a bit, because I liked a lot in the presentation the joke about the 3/4 sync replication, and I couldn't stop myself asking what were the points in your mind that triggered that joke, that the transitioning from semisync to 3/4 sync. What made it 3/4 sync replication?
Yeah, that's good question. Well, of course, I afforded this metaphor, maybe abusing these arithmetical rules, but who knows? Some users that struggle with recovery, they now happy, and they may their application may be, already configured or designed to provide synchronicity as it needs the application. But the semisync, its framework design never considered some important features in order to be called fully synchronous. So, and now having a recovery working, we actually can focus on that part. So it's really some technically not that difficult because we're already having communications. So we should implement it that, say, communication library is in already. We just need to make it working a specific way that, say, sustains partitioning in network, so that slaves and masters could come back to compose a configuration. And yeah, there are this sort of logics not in place now, but so maybe that's about 1/4. That remains.
I see. So that triggered the transitioning, and you say, how far would you think we are from with semisync from reaching the fully sync replication properties?
Yeah, that will take us, of course. At current state, semisync provides some validation to master to commit a transaction. But there are some rules designed, almost hard-coded, how to behave in case of, say, slaves never acknowledge transaction from the master. In this case, there is this timeout and the master commits. So that breaks synchronization guarantees, because it could be that various scenarios could be considered where this behavior is in principle not correct. So we now should consider how this acknowledgement system behaves and improve it. This is one thing. And second, which currently semisync misses, is automatic master election. That can be also covered with some pieces of logics.
I see. But would that be very complicated to implement? What's your instinct saying about this?
Algorithms very much developed. We can refer to group communications, Foracle or our Galera. So they basically implemented this sort of algorithm. However, we having this, I don't know, advantage or specifics, how to call it, having communications already in place. We don't need to write TCP protocol from scratch, so that we will do something on top of it. So go ahead. Do you have anything to add? So that part we again can compare with the known synchronous replication implementation that I just named. They also have the specifics of committing transaction in multi-master, sort of, well, supporting multi-master rather, so that conflicts are detected and resolved. But we can also shortcut our ways to not do that, to stick to the primary master initially. And then everything looks to be very much simpler in order to implement those parts that are missed.
It's awesome to hear that the ideas are put in place, and we have a clear objective for the near future in replication, and I like that quite a lot. Now I have a more technical question, and because it's a bit longer, I'd like to ask you to not mind if I'll read the question, because I noted it. It's something that didn't think in my mind when I watched your video and the diagrams with the coordinator and the master and the binlog pipe, and I'll try to read it now so that I don't get the details wrong.
Mm-hmm.
So when you display the multi-branches case with the vectors,
multi-transaction.
So what I didn't understand is why is that the
multi-engine. I want to say, sorry for interruption.
Yeah, the multi-engine. Yeah. So I didn't quite understand why is that the mixed vectors of the committed and not committed branches, because you had a vector with mixed and with committed and not committed, a mixed vector. At some point you said in the recovery protocol, those mixed vectors are considered like committed transactions. This is a bit counterintuitive to me, because usually I would expect that if one component of the vector is in doubt, like you called it in the video, the entire vector should be considered in doubt. And that's why it didn't ring in my mind. It was not intuitive. Would you like to explain this a bit?
It was considering the size of the whole presentation. I didn't delve into this part. It's not really too much practical, but still, if we have resolved it, then that just makes more confidence to the solution. And according to, we have thorough review process, and I already spoke this gratitude words to the reviewer, Sergei Golubchik. So this was analyzed very thoroughly, this part. So to the question, yes, just compare a single case against multiple engine case. When in the single case we have at least one prepared, and this is just only one engine, then the doubt is resolved automatically. So in multi-engine case, we have one engine. Just one engine is enough when it is committed. Then we don't have way back. That's a constraint, a logical constraint we cannot overcome. We have to consider it as committed and do our best to commit everything. So. And if you remember on presentation, there was this range of committed with capital letters.
With capital letters and superscripts, and then,
And so what we would have in binlog, we would have, if we consider indexes of vector as independent transactions, we would have this G capital until some point. Then same multi-engine transaction starts. It could be one engine non-committed. Then we would have G smaller case. Then another engine of that transaction committed, then uppercase. And so we would have this various cases G. But finally, it all ends with either end of file or fully only maximum prepared or even not prepared transactions. So we would have compare the single engine with multiple engine. We would have this perturbancy sort of area in the binlog, which I explained why we must account even single indexing in the vector. In the presence of a single index in the vector, we have to account the whole transaction as committed.
Yeah, I get it now. Thanks a lot.
Was welcome.
Thorough explanation. Yeah, thanks. I have one last question for you. Then we can move on to the next presentation. And the question is, while you cover the multi-engine case, do you actually have to make any changes to the logging format of the replication events in binlog?
Right. So basically, we can now continue with the question you asked, how we know that multiple engines in the first place when we analyze binlog events. So before in the base code, we have GTID event describing transaction, and we also have XEED event describing transaction. GTID is better for our purpose, even though in the central single server recovery, we use XEED information. So now we turned our implementation to GTID because it is more descriptive.
It offers a more spectrum of information, more dimensions to play with.
Indeed. And then, you know, as a side effect, you can ask me next time that what we're going to do with exceed event. Do we need it at all?
Yeah.
Yeah. The answer is no. We don't need it in the future. But
well, if it produces less overhead in development because it's a simpler concept, I think it's still worth to keep it. Right.
The end of the transaction must be somehow indicated, and we could make many things to optimize, but it's just an area we could go in. But to the question, so GTID is augmented to accept few more markers in it. So we have to specify number of non-transactional engines in the transaction, number of transactional engines in transaction, and we also have to account cases where both can be zero. We also have this specific, so sort of legacy logging, where ineffective transaction, which doesn't update data, still ends up in the bin log. We have this situation.
Yeah.
So that's how we manage to do it.
That's
so for this, edit counters.
I see. Andrei, thank you. That was very educative for me because I'm kind of a fan of replication. I'm trying to learn as much as possible. I don't have enough time like I would like to investigate this domain, but I'm trying my best. And thanks a lot again for presenting, and hope we'll chat again and work together again in the future.
Yeah, thank you, Robert. For questioning for the users, and all the best. Bye-bye.
Bye.
Hello everyone, my name is Alan Cueva and I'm from the Technological University Dublin, and today I'm going to talk about my participation in the Google Summer of Code at MariaDB in the project Custom Formatting of Strings in MariaDB Queries, but I was not alone. Vicentiu Ciobaru helped me as a mentor of this project. The aim of this project was to create a new function similar to printf in C and format in Python to avoid complex select statements full of concat and format functions. We have two examples here. One is in the printf way and the other is in the format way. We should remember that the format function already exists in MariaDB, so we use sformat. And the idea here is not only to concatenate constant strings and argument, but also to give some format to those arguments. Checking others database systems, we found that in PostgreSQL there is a function called format, and this function is similar to what we want to do, and it is based on the printf way. In a Google Summer of Code project, the proposal is crucial because it depends on this proposal to be accepted in the project. So in this case, I designed an algorithm based on 3 steps. The first one is to split the string formatting argument, then apply a format to those to the arguments, and at the end to make the concatenation of the string. As we can see in this example, the split separate the string constant and and specify the format of the arguments. We have an example and without any specification, so we put empty and the other with the specification. And in the apply format step, we're gonna take the argument and convert it to a string, applying the format, the custom format. And at the end, it just matters to concatenate everything and return the result. The advantage of this proposal is this is a simple solution. I mean, if you saw it, the solution, if you saw it like an overview, it is very simple. The split, apply format, and concatenation. And the design, it was designed to add new formats and data types just by changing the format, the apply format step. Some of the disadvantage is the split step. This step is very complex, and it have to have many exceptions like double brackets, some bad format, and we found some problems with the UTF-8 characters because it based on the brackets, and it could be some problems with other characters. You know, this split step should be safe because segmentation fault errors are not allowed in MariaDB and in any other database system. And another disadvantage is that it could be too much work to implement every possible format case. So it could take too much time. Methodology. In this case, the idea is to have a loop, because we know we have many versions of this solution, and at the end it's just a matter to add new apply format options. So the idea was to do the developing, do the testing, and the verification. In this case, the verification was made by the mentor, and it is a source code verification. And at the end, when we are happy with everything, we could do the deploy after many loops, as it was the case. In the implementation, well, this proposal was accepted. So we decided to go to the format way, with the Python way. In this case, it was very easy to start because the concat function already accepts an undefined number of arguments. So the first prototype of this function was a copy of the concat function, and for this it was only necessary to create two new classes: the create func format and the item func is format. And we also create a specific test case just for this function. In the challenge that I faced during this project was the string, working with the string, the MariaDB string class. In this case, this string class is focused on charset, so it's very different to the string class, the std string class, and well, other string classes that I saw in C++ and other languages. So there is no documentation about it, but but it's everything in the definition of the class. So that should go to the header file, see the definition, find examples when it is used, and at the end I ended learning how to work with this string function and many other functions in this class and many other functions in the MariaDB core. The good thing here is like the magic behind MariaDB is the community, because we have a chat when we discuss some problems, some approaches, and the community was always there to help us. And especially in one moment, Karkit suggested us to use a library, an FMT library, who is a promise model library that do exactly what we want to do in C++. So after some analysis from my mentor and checking some options, we decided to use this function because it's very safe. It helps us a lot. All the problems with implementation, all the apply format was already solved by this function, by this library. So we decided to use this library parser. And in the end, we used this library. We copied the source code. Obviously, this is an open source code, open source project. So we put it in MariaDB. We implemented, and we solved the problem. But we are limited by the format implemented in the FMT library. We have an example here when we create a table with many different types. we have a format with many different specifications, and we can see the result. These specification strings are not the same that we have in the format function in Python, but are very similar, and after many tests it proves that it works fine. For future work, well, in the Marietv database code we have some logs, alert, etc. that could be take advantage of the library. If you check the GitHub page of this library, there is some testing that prove that it is faster than many others file writings or printf functions. So we can take advantage of the code that there is in MariaDB, that is already in MariaDB after this project, and use it for the logs, for the alerts, and many other stuff. Also, for future work, we have to create new formats for specific types, for specific MariaDB types like decimal, and possible new formats for data types, because right now it's only printed as the way that the MariaDB convert a data type to a string. So it could be useful to have many different specification format exclusive for data types, for MariaDB data types. And thanks so much for listening. That's all for my part.